Most of us assume that what you see is what you get. We assume that the moon is there, even if you don't look. The bottom line is the probability is zero.
All right, so reality is not the way that we perceive it.
You don't see the truth. The reason is because it's infinitely complicated.
If a tree falls in the forest and no one's around to perceive it, does it still make a sound?
This has been a big problem in science until I discovered the trace logic. And just 6 months ago, I think I found the key that I've been looking for 40 years. This is the first time I've actually talked about this. But the interesting thing is, spiritual traditions have been saying this for thousands of years. And now the best science says that. The best science does not say you're just a lump of atoms that happens to have some consciousness. Now the smart money is on, yeah, you and I are one. From this bigger point of view, there's infinite exploration, and the exploration is you. And a lot of the exploration will be done, as the mystical traditions have said, in silence. And that silence itself is tapping into this infinite wisdom that everybody is.
Hey everyone, welcome back to the Know Thyself podcast. Our guest today is back for the third time. We love him so much, and I'm excited to dive into this conversation exploring the nature of reality and its many different aspects. He is a cognitive psychologist, an author, a consciousness researcher, and somebody whose extensive research in both consciousness and evolutionary game theory has positioned him uniquely to be a pioneer in emerging discoveries around the nature of reality that really shakes up our intuitions and notions of what it is in the first place. Donald Hoffman.
Thank you, Andre.
Good to be back.
That's great to be here again, the third time. Thank you very much for having me back.
Yeah. I think it's going to be great to set a bit of the framework and set the stage, not assuming people have tuned into the previous two conversations. Let's start off very baseline. Can you explain to the layman how we don't see reality as it is?
Right. So most of us assume that what you see is what you get. I see a car, that's because there really is a car there. I see the moon, that's because the moon really is there, and so forth. And we assume, those who know evolutionary theory, for example, might say, well, and the reason we know that we see the truth is because we evolved to be fit. And to be fit, you should see the truth, right? The more accurate your perceptions are, the better you should see the truth about reality. And those who think that this isn't reality, if you don't think that car is real, if you step in front of it, you'll find out that it is real, that it can hurt you. So those are the kinds of intuitions that we all have. And it just turns out when you look at evolutionary theory carefully. So Darwin didn't have mathematics. He gave a beautiful theory, but there wasn't any mathematics. But John Maynard Smith in the 1970s mathematized Darwin's ideas, and it's a field called evolutionary game theory. And so now we can take out Darwin's ideas and look at mathematical theorems about what's entailed by his theory. And you can ask the question, what is the probability that organisms are shaped by evolution to see aspects of reality as it is, truthfully? And the bottom line is the probability is zero. That's the bottom line. When you do the math, the probability is zero. And the reason is slightly technical, but not too hard. And that is, there's something called the fitness functions, right? They describe for a given organism, if you take this action and you're in this state, what the consequences, the fitness consequences will be for you. And by fitness, evolutionary theory, of course, means the chances of successfully reproducing. So that's the measure of fitness that we're talking about, the probability of reproducing successfully. So when you look at these fitness payoff functions, since they're what's shaping the sensory systems of the organisms, right? That's what's shaping evolution in evolutionary game theory, these fitness payoff functions. They depend on the state of the world, the organism, its actions, and you get a payoff. Like, for example, just to be very concrete, if I'm a human being and I'm standing in the middle of the 405 freeway at 10 o'clock in the morning, that's a bad place to be, and my fitness payoff is death, right? That's really a dumb thing to do. So whereas, so you can see, you take an organism, put it in a place, put it in an action, and then you get a number, thumbs up or thumbs down for your fitness payoffs. So these are functions, and for those who know some mathematics, they are just functions. And it turns out there's no constraint on these functions in evolutionary theory. There's no constraint that says they only have to be continuous, or they have to be quadratic, or there's just there's no constraint from the theory. So Darwin's theory doesn't tell us these are the kinds of functions. So given that, we ask, what is the probability? We can just look at the space of all possible fitness payoff functions and ask, how many of them will shape organisms to perceive aspects of reality? Very, very, you can just assess it with mathematics. And it turns out 0%. Zero, it doesn't mean none, but it means 0%. So if you're a betting person, the good bet is against seeing the truth. Now, someone can come back and say, well, I don't like that. I mean, and a lot of people do. They come back and say, I don't like that. And my attitude is, that's perfectly fine. I have no skin in the game. I don't care. I'm just telling you what the current theory says. The current theory says all fitness payoff functions are equally likely. And I say, okay, they're all equally likely, then the probability that you see the truth is 0. Now, someone can come along and say, well, then I'll show you why they're not all equally likely. Perfectly fine with me. Go ahead and do that. But I haven't seen anybody do that. But that is the right response to my... Now, here's a response that I get a lot that is, I think, a mistaken response. The response is, look, Darwin started his theory with physical organisms competing in space and time for physical resources, like mates and food and so forth. And now you're saying you're using Darwin's theory, a mathematical version of it, to prove that the probability that space and time and organisms and food and so forth are almost surely not the nature of reality. So, Hoffman, you should go learn some logic. You started with the assumption of space and time and physical objects and payoffs, fitness payoffs for food and so forth. And now you're saying that that physical stuff is not the nature of reality. You've shot yourself in the foot logically. So go back and learn some logic. And this is actually, I mean, this is not just informal. I mean, there are philosophers who published papers on this where they, in prestigious journals, where they make exactly this kind of argument that I've caught myself in a logical bind. And so this raises an important point about science. And it's very elementary. Scientific theories start with assumptions. Like Einstein, special theory of relativity. He started with the assumption that the speed of light is the same in all inertial frames, and that there is no special inertial frame. The laws of physics are the same in all inertial frames. And he said, if you grant me those two assumptions, then he could build actually relativistic spacetime with all the changing clocks and meter stick lengths and the whole bit came from those assumptions. But he didn't explain the assumptions. He assumed those assumptions. And actually, toward the end of his life, Einstein said, I still don't know what light is. I've spent my life thinking about light and working on light, and I don't know. So he doesn't know why the speed of light is the same in all inertial frames, or why all inertial frames have the same laws of physics. But those are his assumptions. And this is true of any scientific theory.
And when you say that, by the way, you just mean the speed limit on the universe, essentially.
Right. Nothing can go faster than the speed of light.
Mm-hmm.
So,
and he didn't want to spend most of his life figuring out why, but just kind of went with that assumption.
Oh, I think Einstein wondered a lot about why.
Yeah,
but he couldn't answer the question. If you assume it, then you get the structure of what we call Minkowski space coming out of it. And of course, I think you can, with any scientific theory, you can say, I'll give you a new set of assumptions that are deeper, and from my new set of assumptions, I'll explain your previous assumptions. But here's the key point. No scientific theory can ever be a theory of everything. Period. Anybody who doesn't have a wink and a nod when they talk about their theory of everything is missing the point. I think a lot of brilliant physicists who talk about a theory of everything know that they're not talking about a theory of everything, but they really just mean the unification of certain theories that are not unified now. But there are a lot of people who think that we could get a theory of everything, and I'm saying no, never. Even if we worked for 1 billion years and had 1 billion Einsteins working for 1 billion years, we would never have the theory of everything. We'd get 0% of reality. And the reason is every theory starts with assumptions, and it doesn't explain its assumptions. It assumes them. And therefore, every theory has two properties. If it's a good theory, it has a scope of explanation. So there is a scope of things that it can explain. By the way, most theories don't. Most theories, and I get them in emails a lot, most theories have no scope whatsoever. There's nothing there. But a good theory has a scope, but it's a limited scope. It's not everything. It's not a theory of everything. And then, so they have a scope, and they can tell you, if it's a good theory, they'll give you mathematics to explore that scope. But if it's a great theory, not just a good theory, but a great theory, it will give you the tools to figure out the limits of explanation that were entailed by the very assumptions that started the theory. Because a theory must start with assumptions, it has limited scope. The only question is, does the theory itself give you the tools, is it a great theory, to give you the tools to find that necessary limit or not? And what I'm saying is, Darwin's theory, with John Maynard Smith's mathematics of evolutionary game theory, is a great theory. We knew up front that it couldn't be the final theory of everything, and it turns out to have the tools to say that its very foundational assumptions, of course, are not the final truth. But we knew that that's true for any scientific theory. You give me a scientific theory, tell me its assumptions, and I will tell you something that's not the final truth. Those assumptions. So a theory that gives you assumptions that lets you come back and tell you that those assumptions aren't the final word on truth is a great theory. And those are the theories that we look for. So it's for those who have said that I'm shooting myself in the foot, they completely misunderstand the foundations of science itself and the scientific enterprise. It's not the false interpretation is science is the crawling towards the ultimate truth. And we're going to get there, maybe, who knows, maybe this century we'll get there. That's just false. The right approach, or I'll put it this way, a deeper approach to understanding science, is to note that every scientific theory starts with its own assumptions. And therefore, it has limited scope of explanation. And if it's a great theory, it will use its own assumptions to show the limits of those assumptions and to show that they can't be the final. But most theories aren't that good. I mean, Einstein's theory, it's Einstein's theory, I must say, together with quantum mechanics. So quantum field theory together with, which brings together quantum mechanics and Einstein theory, and also general relativity. Together, that package tells us that space-time cannot be fundamental. So that's in the physics side. And in Darwin's theory by itself agrees that physical objects in space-time can't be fundamental. So here we have quantum field theory and evolutionary theory telling us that space-time and its objects are not fundamental. Now, we already knew that none of our assumptions are fundamental. It's just great to have these theories being so powerful that they're telling us that these assumptions are not fundamental. So that's the fundamental orientation that people need to have about this thing. It's not about shooting yourself in the foot. No theory has the final assumptions. Some theories are so deep that their assumptions tell you that the assumptions aren't true. They're not the final word. But most theories aren't that good.
We're going to keep diving into all of that. But to keep making our way through this in a digestible manner, I'm curious because when you speak to how the likelihood that evolution has shaped sensory systems to, see objective reality is effectively zero, and perception is reality in so many ways. As human beings, we kind of share generally a similar sense through our sense perceptions and sense organs, this experience of life. And it seems like we see reality as it is because it's ubiquitous within our experience. It's all we've known. And yet, I think what's helpful in seeing and breaking down this notion of it being connected to what reality actually is seeing the variance in how perception occurs within all life. And so I'm curious, what comes to mind when you think about all the different life forms and animals and their sense organs and how they perceive reality? Where if you put them side by side to us, our experience of life is completely different, and yet we both feel like it's the way reality is to us because it is for us.
Well, that's a great question, and there's a lot to say on that. But one thing I'll start with is to point out that I actually don't know what your perceptions are like.
Right.
I
Can assume.
That I pick up this cup and I say, yeah, it's sort of a cup that's got some bends in it and it's got some tea in it, and you would agree, but I have no idea what your experience is. I assume that it's very much like mine. And part of this is because we learn to talk by something called ostensive definition. So if you're a child, and your mom or your dad is there and you're like 18 months old and it's time for you to learn some words. And there's a rabbit on the floor. And mom or dad points and says rabbit. And if the child's at the right age, they get it. You only have to point once or twice and say rabbit. But if the child, right, if you did it when they were 6 months old, it doesn't work. It doesn't work. And if you do it with a rat, it doesn't work. If you take a rat and point to a rabbit and say rabbit, it doesn't work. Why doesn't it work with the child? Well, the child already had its own experience and conceptualization, so to speak, organization of it as a rabbit. And so all you do as a parent is you give the words for the experience that the child already has. You're not giving the experiences. The child's experience is whatever it is. And you don't know. How can you ever know? For all I know, your world could be utterly different in conscious experiences. Mm-hmm. Now, you of course you want some empirical evidence for this.
But it is also just important to highlight that even within the spectrum of human experience, there is variance that we do know of, and there's also a lot of variance that we don't know of that we just assume that is the same.
That's right. So in color, we assume that I talk about the green plants here and a little bit of red in the carpet and so forth. And I assume that your experience of red and green and so forth is very, very similar to mine. But there are women called tetrafemmes who have 4 color photoreceptors instead of 3. Most of us have just short, medium, and long wavelength photoreceptors, and these women have 4 instead of just 3. And they're called tetrafemmes. And I'm actually friends with someone who's done research on this, Kimberly Jameson and others who have done research on this. And they can do genetic tests, and they find these women that have the gene for being tetrafemmes, and put them in psychophysical experiments where you test their color discriminations, and they're finer than ours. They actually have different color boundaries and finer discriminations. They can see, maybe an order of magnitude more colors than we can. So we already have empirical evidence. Again, we don't know what it's like to be a tetra. I don't know what it's like to. No guy could ever know, and most women could never know. But even if you're a trichromat just like me, the fact is I have no idea what your experience is like. I assume, and I'm not saying it's a bad assumption. I'm not. If I had to bet, I'd say there's no reason for me to disbelieve. But I just want to point out that it's a belief. It's not a proven fact. It's a belief that your perceptions are similar to mine. Here's a fun technological thing that someone could do. I think that we could write a multi-person AI first-person game where people around the world could be, put on a headset, be immersed in a game. that they're all playing internationally, but each headset is actually a very, very different looking game. But there's a translation. So maybe I'm playing tennis in this one, and you're playing badminton in that one, and someone else is playing, Grand Theft Auto over there, and we're all playing together. Even though you're playing Grand Theft Auto, I think you're playing tennis with me, and I think that you could actually coordinate that such that I'm playing and we're all interacting. But then when you change headsets, you go, holy smoke, you were playing a completely different game than I thought you were playing. And I think that would be fun to do, to really shake people up and show that the assumption. Now again, I'm not claiming that we're not seeing the same game, but I'm saying it would be fun to shake up the assumption that we are by putting together a multiplayer VR situation where, as you change, like a dozen different headsets, and every one of them is a different world, and you're doing something entirely different in the world, and yet they're all coordinated. Mm-hmm. So I think that's eminently possible, and that would really go a long way to shaking people up. And again, for all I know, your experiences are very much like mine.
Yeah, but it is interesting how we are really only always speaking in approximations, and language is always going to be futile, and it helps us kind of speak about reality in a sort of agreed upon shared sense that is a lie fundamentally, but like we can just kind of approximate what we perceive on the less than 1% available to us on the electromagnetic spectrum.
Yes.
But we know that before we even get into different animals and what their experience is like, that depending on the state of consciousness that we're in, and we could very subtly tweak our biochemistry exogenously, endogenously, psychedelics, many different things.
Right.
And the experience of reality changes so drastically by very minor changes. So it's just, fascinating.
Little DMT and you're in a different world.
Yeah.
Completely different world. And then for a lot of people, then shakes up very much the assumption that what I'm seeing is reality. I haven't done it.
Yeah.
But lots of people contact me and say, I have done it, and I like your theory because when I go on the DMT, it says you're... And so I didn't come up with a theory because of DMT, but I get people with DMT saying this really works. I've
seen a lot of comments on previous episodes of both the ones we've done and others where people who have explored psychedelics or DMT, for example, have really resonated because there is this fundamental, effect of your work, which is shaking up our notion of preconceived notions of reality. And so, let's keep going. So what are some other examples of life that has different access to different parts of the electromagnetic spectrum with their own sense organs that you find interesting?
Right. So some birds can see the polarization of light, and they use it to navigate. I can't see the polarization of light. I don't know what it would be like to experience the polarization of light. You can get a little sense of it if you wear sunglasses, right? And things look darker when I look over there and a little bit brighter when I look over there. So you can get some sense of it, but we're not actually built with polarization. There are all sorts of, there are animals that see frequencies of light that we can't see, ultraviolet or infrared. It's truly stunning, the range of other experiences. There are some that can experience electric fields, so they actually have electroreceptors, and they actually use it like I guess in water, sharks and so forth. I'm not sure about sharks, but certain animals can use electric fields to detect prey and capture prey. And again, I have no idea what it would be like to have an electric field around me and using that to detect prey. There are some wonderful books out there about just how different the animal senses are. So it's easy to find books.
Mm-hmm. All right. So reality is not the way that we perceive it. I think we can all agree upon that. And so then walk us through a little bit closer now to your understanding of sort of space-time being a headset. how do you bridge us into the deeper implications of your work exploring consciousness and yeah, when you say space-time, this is
Right,
like a
right,
headset that we're wearing,
right.
just like when you're playing Grand Theft Auto, it seems like this reality. And if you have a VR headset that you're playing, it seems like the reality that you're immersed in because you're so plugged into it and it's so enchanting in your experience of it.
Right.
Um, but if perception is not objective reality, then what is perception?
Right. So we can go back to evolutionary theory on this. So if I'm saying Darwin's theory entails not that we see objective reality, but it's shaping us to be fit. What does that mean? I mean, most of us think, well, the only way you could be fit is to see reality. And these virtual reality games give a different idea about that. If you're playing Grand Theft Auto VR, then what you're really interacting with in this situation are millions of diodes and resistors and voltages in some supercomputer somewhere. And in principle, you could play the game by toggling millions of voltages per second in exactly the right sequence. You have to be really, really good, but it'd be millions of voltages per second. It'd have to be exactly the right sequence. Everybody who's programmed, you get one bit wrong and the whole thing falls apart. So you could do that, but you would lose if you tried to. Even if you wrote the program, you would lose if you were trying to toggle all those bits one by one against someone who had just a VR headset and had a steering wheel, a virtual steering wheel, and was trying to play the game that way. And so the person with the headset, with the VR headset, is going to be more fit, more likely to win at playing the game of Grand Theft Auto than the person who sees the reality and can toggle the bits. And so that's the notion of fitness that comes out of Darwin. You don't see the truth. And I think the reason is because it's infinitely complicated. Reality, whatever it is infinitely complicated. There's no way, period, to understand it. So it's just off the table.
It would defeat the purpose of having an experience that allows us to effectively navigate anything.
That's right. So so reality is what it is, and it's infinitely complicated. We have a little trivial three-dimensional space, one-dimensional time headset that takes this infinity of complexity and puts it down into what looks to us like a complicated world, but it's 0% of the complexity of reality, 0%. And that's what Darwin's theory is telling us is this is a headset that is here to keep you alive in this particular game. The game of being a human being, reproducing, having a job, whatever. In that game, this is the headset you need to play that game. If you're an elephant, it's a different game. If you're a worm, it's a different headset. But space-time then is not the final ground of being. It's a trivial headset. It's a trivial framework compared to what's available. And I should say that, I've used Darwin on this, but someone might say, well, look, Darwin's not a physicist. He's not an expert in space-time. I mean, we should go to those people, the experts. And those experts are so-called high-energy theoretical physicists. That's the right group of scientists. What do they say? Do they come along and say, no, Darwin was wrong, space-time is fundamental, and get used to it, Darwin was just wrong? No, they don't say that at all. They say, and I'm saying like Nima Arkani Hamed, David Gross, and others say space-time is doomed. By that they mean it's not fundamental. It falls apart at 10 to the minus 33 centimeters, 10 to the minus 43 seconds, at what's called the Planck scale. It ceases to have any operational meaning. And so physicists, again, high-energy theoretical physicists, so when I say physicists, I'm short for high-energy theoretical physicists in this context. So these physicists are saying that space-time is not fundamental, and we have to look for a deeper mathematical framework entirely outside of space-time. And that's not just a distant wish. They're doing it now. The European Research Council has a 10 million euro enterprise funding roughly dozens or even 100, I think, physicists and mathematicians who are finding what they call positive geometries outside of spacetime. It's really quite exciting. They're finding these,
like the amplituhedron, or is that
the amplituhedron is one of them. The cosmological polytope, associahedron, and other structures. So they're finding these almost like these monoliths outside of spacetime. These big structures, complicated geometric structures, and they allow you to actually predict correctly the probabilities of interactions. This called scattering amplitudes for interactions of particles in spacetime. So they know they're onto something, and the math is much easier. What would take millions of terms to compute within spacetime, like some gluons and photons and whatever, and quarks interacting, they can do much more simply outside of spacetime.
Is it a rudimentary understanding to say, like, you wouldn't expect to go into a vacant field where no one has been and there's no form of intelligence and see a Taj Mahal structure there, for example? That would denote that there is some sort of there was a intelligence weaving some sort of structure, or a builder, an architect to some degree. When you look at these cosmological polytopes that
Right.
you discover in the mathematical sphere, like, what question does that raise about, I guess, the meaning or why they're there?
Well, it raises all sorts of questions. We didn't know what to expect. We're taking our first little peeks outside of spacetime just in the last, say, 15, 20 years, right? We realized, I think they knew before that spacetime isn't fundamental, but what do you do? How do you go outside of spacetime? What's your research agenda to do that? How do you do that? And so it's taken some very, very clever researchers to sort of say, well, how are we going to go out? I mean, I can't even see outside spacetime, so it's going to be with mathematics and intuition and logic that we're going to have to try to go outside of spacetime. And so what they're finding, so they are surprised. They're finding these geometric structures, and the volumes are coding probabilities of particle interactions, and the structure of the vertices and so forth, the edges is coding for things like what the unitary evolutions and so forth, and so it's a bit surprising. They're not seeing what they're not showing is the dynamics, right? You might say, "Oh, well, I expect to go outside of space-time and see something moving." Although it's hard to know what it means to be moving outside of space-time, right? I mean, moving in space-time means over time something changes its space position. So you want some kind of dynamics, but not a dynamics inside space-time. So I think that, they're brilliant. They're finding what they can find, but it's not a dynamical system. It's these objects that encode the dynamics that we can see inside spacetime. So it's connected to dynamics we see inside spacetime. But what I haven't seen them doing is saying, I'm going to posit this dynamical system outside of spacetime, and then show how it projects to the dynamics we see inside spacetime. So it's more of the line of, we step outside spacetime. What can we find outside in terms of geometries that will predict what we see inside spacetime? You have to go outside of spacetime now. The game is not complete inside spacetime. You have to step outside spacetime. So that's going to be really critical for theories of consciousness too.
What's the one-liner or two-liner for people, like, when you say space-time, what are you speaking to directly? What is space-time?
Under Newton, Newtonian physics, space was three-dimensional and Euclidean, and time was the same in all places in space. So there was one big clock, and everybody had the same clock, and space itself was nice and Euclidean. Einstein, in the special theory and general theory, effectively said, it was actually Einstein's teacher who put this together, Hermann Minkowski, but based on Einstein's work, that space and time together form a single mathematical object that we now call Minkowski space, and we call it space-time, in which you can trade off a little bit of space for a little bit of time. So as opposed to having a single clock that's true for all observers,
Mm-hmm.
There are different clocks for different observers depending on how fast you move, and different lengths of rulers depending on how fast you move. So it's not the nice, clean, neat space that we had with Newton. This is really much more interesting, where space and time trade off. There's no universal clock. Your clock, if you're moving, I mean, the fact that I just move like this with respect to you means my clock moved differently than yours during that time. We had different clocks, and also lengths were different for us.
You see this as an example in the movie like Interstellar, where he goes on a space mission, and depending on where he goes, obviously time relative to the human clock on Earth is different, and he comes back in like 30 plus years or whatever has elapsed in earthly time. But it might have been, I forgot what it was, maybe like a certain amount of 6 months or a year or something in terms of how far where he went.
That's right. So if you're moving with respect to me, I'm sitting here, I'm thinking of myself as being still, and you're moving past me at a uniform speed. If you're at a uniform speed with respect to me, you're not accelerating, then I will see your clock as going slower. And as you approach the speed of light, if you're going near the speed of light, I will see your clock very, very close to not moving at all. And if you are going the speed of light, I will see your clock has stopped. But similarly, if I'm not accelerating with respect to you, and you're looking at me, you're going to see my clock going slower. You're going to think your clock is going just fine. You're going to see now if you accelerate, that's different. Acceleration is not relative; it's absolute. So that gets more complicated.
Wouldn't it be true then somebody at the core of the Earth, or maybe just say like at sea level, would be traveling, time would be moving faster for them than somebody like at the top of a Mount Everest or something?
That is true. The clock depends on the gravitational field where you are, but it's because
time moves slower in the mountains.
right, but because you're accelerating less, so it has to do with the acceleration.
It's all comparative, yeah.
Yeah, that's right.
Okay. Yeah, we can, there's so many sidebars here, but let's just kind of get back to the notion that our perception is obviously not objective reality. And to go further down the rabbit hole of psychosis, or I joke, but really what it means to be sane is to see and understand, experience reality at closer to the objective sense. Things are not rendered when they are not perceived.
Right.
So for people if that's a foreign notion to people, can you explain what that means, both in the mathematical sense and the philosophical sense, I guess?
Yeah, that's a really an important point, and that is that we assume that the moon is there, even if you don't look. Of course, it's there, and that car on the freeway is there, even if you don't look. And if you don't believe it, don't look away, and when it hits you, you'll know that it was real, right? So people say, it exists whether or not you look, and I'm saying that the car that you perceive is very much like if you have a VR headset on, you're playing Grand Theft Auto, and you're looking around, and you look down and you see your steering wheel. So there's a steering wheel when you look because you're rendering it. But if I look off to the side, now, since I'm not seeing the steering wheel, there is no steering wheel. There's no steering wheel anywhere at all. That steering wheel is gone.
Except for potentially somebody else's experience who's rendering it.
Yeah, but they'll have their own experience, right? So, but if you look inside the supercomputer, there's no wheel in there. There's just digital bits and circuits and software. So I render the car, I render the steering wheel when I look, and I garbage collect it. I get rid of it when I look away. Someone else may look, but their experience of a steering wheel is not my experience of a steering wheel. It's their experience. Mine is gone. There is no, in the real supercomputer, there is no steering wheel anywhere. There's just bits. So that's what I'm claiming is true of all of the world that we see around us. You render the moon when you look. and there is no moon when you don't look. I render my foot when I look, and there is no foot when I don't look.
When you say there is no, would you apply that to people? Because when you say there's no Don when I don't render him, yeah, in your experience, Don is certainly there, and somebody else's experience, you're certainly there.
That's a very deep question, because now it gets to the question of what am I really, and what are you really, right? So if you want to say, well, no, Don is really just a 160-pound piece of human flesh and blood and so forth, and that's all there is to Don, I would say that's within the space-time framework, and we know that the space-time framework is not fundamental. No object in space-time is fundamental, and that includes your body or my body. Whatever you are not an object in space-time. To the contrary, space-time and everything inside space-time is a creation of yours on the fly. So I'm turning the whole ontology around. Most of us assume that we are little 100 to 200, 300-pound objects inside a vast space-time universe. I'm saying that's false. That vast space-time universe is a tiny headset that you're using that you'll discard. And it's just one of countless headsets that you, whatever you are, can use. So when you ask, is Don really there? Well, in this VR game of space and time, this pretty trivial headset, Hoffman's body is rendered when you see it or when I see it. And I don't know that what you see is what I see at all. We use the same words because we learned them by ostensive definition from our mothers, and our mothers use the same words in the same context. And I'm not saying they're not the same. They may be, but we don't know. But whatever I am is not an object in space-time. Space-time is a trivial framework for us to experience a projection of who we are.
Hey guys, if you're looking to add a simple but powerful health tool to your daily or weekly routine, I recommend checking out Bond Charge's red light devices. I usually use mine during my morning meditation, and it's helped with everything from energy and mood to skin health and sleep. Red light therapy is backed by thousands of studies, and it's a great way to get healthy light exposure without messing up your circadian rhythm. Bond Charge stands out because their devices have the lowest EMF levels, there's no flicker, and they have both near infrared and red light in one lightweight device. They ship worldwide and also have an array of other science-backed wellness products worth exploring. If you want to try it out, you can go to bondcharge.com/know thyself and use code know thyself for 15% off. That's BONCHARGE.com/know thyself. All Bond Charge products are HSA and FSA eligible, giving you tax-free savings of up to 40%. I hope you enjoy. Back to the show. So when you say the very well-known phrase or question of if a tree falls in the forest and no one's around to perceive it, does it still make a sound? I suppose it begs the question of what do you mean make a sound? Because that is a subjective experience to an observer. And if there is no such observer, then it would not. Is that right?
Right. That's what I'm saying is that, and this gets to, yes, it gets to a very deep point though, and that is that what do we mean by making an observation? And this has been a big problem in science. So in Newton, it was assumed that the observer just sees reality as it is, and you could ignore the observer because the observer didn't affect what was being observed. So Newton didn't really need a theory of the observer. You just see the truth. With Einstein, there's a notion of an observer, but it's mostly just different observers are different clocks and coordinate systems. And there's no really deep theory of the observer beyond the clocks. In quantum theory, now you're forced to consider what you mean by an observer, because quantum theory says that when you don't observe a system, it evolves according to what's called the Schrodinger equation. It's a unitary evolution. But when you observe a system, then empirical experiments tell us that what happens is not a unitary evolution. You get a single answer. Like for an electron or a photon, maybe having some kind of quantum evolution under the Schrodinger equation. But when you then, and the superposition of all these different paths it could be taking, but when you make a measurement, you get a dot on the screen here. And so that's where the electron or the photon landed. And so you get a single answer. And that's not a unitary process. And so that raises a deep question about what do we mean by an observer? And quantum mechanics really can't avoid it. The problem is that if you want to say, well, an observer is just any physical measuring device. And many quantum theorists have said it. It's just a physical measuring device that takes the superposition and gives you a single. Well, no Schrodinger evolution described physical device can do that. A device that does that does not satisfy the Schrodinger equation. So we have a problem. If the universe behaves one way under the Schrodinger equation when you don't observe, you can't just call in a measuring device and say, well, it does it. What is your theory of the measuring device? Is it a quantum theory? Then give me your unitary operator. A unitary operator can't give you a single output. So what are we talking about here? You can't be done. They'll say, well, you can do it with what they call decoherence. Well, we can. The bottom line is decoherence doesn't solve the problem. Decoherence gets rid of the complex numbers, the complex amplitudes, and it can give you a real set of probabilities. So you can a set of outcomes with real probabilities, but it doesn't give you a single outcome. So decoherence doesn't solve the problem either. It gives you a mix, what we call a mixed state for probabilities, real probabilities, not complex amplitudes, real probabilities of outcomes. But that's not what happens in an experiment. We get a single answer. So if decoherence is going to work, I want you to give me a single answer, not a probability on answers. So and Frank Wilczek, who was a Nobel Prize winner for his work in quantum chromodynamics, I think, points this out that quantum mechanics needs a theory of the observer. That's really an open, nasty problem. So right now, science does not have a nothing close to a universally agreed on theory of the observer. This is considered one of the big open problems by Nobel Prize winners in quantum physics to solve that problem. So what is an observer? Right now, science doesn't have an answer. It does not have an answer.
How do you explain why the physicalist notion and paradigm of consciousness cannot explain a single qualia or experience, like the reason for that? And then, we'll just set the stage a bit more of how consciousness comes into all of this.
Right. So we have been talking about conscious experiences, and most of my colleagues in cognitive neuroscience who are studying consciousness are physicalists. And they're brilliant. They're good friends and colleagues, and they're brilliant. And they're assuming that space and time are fundamental, and that certain physical systems in space-time that have certain properties will give rise to conscious experiences. So again, it's a space-time framework. Presumably at the Big Bang, there were no conscious experiences. Space and time and physical objects just didn't have the right kind of causal or functional properties to generate or instantiate consciousness. But after billions of years of evolution, you start getting the right kinds of causal structures or functional structures, and so they're again, these are friends and colleagues, they're brilliant, and they have, for example, integrated information theory, that there are certain causal structures that are identical to certain conscious experiences. Or global workspace theory, again, certain functional properties. There's orchestrated collapse of quantum states of microtubules for Penrose and Hameroff, and there's many. I'm just mentioning a few. But the theme behind all of them is there's a physical substrate in space and time that's necessary. And if that substrate has the right properties, the right causal and functional properties generally, then it will give rise to life. And then if it has even more precise properties, that living thing will then give rise to consciousness.
So from the mechanistic or deterministic lens, that since from the origin of the Big Bang to the development of sense organs in neurology, that enough unconscious complexity would develop in a human brain, for example, that would then give rise to a certain point of an experience of itself,
Right.
aka consciousness, awareness. And
Right.
but yet the smell of a flower or the taste of a chocolate or mint, that has yet to be, and probably never will be, especially through your understanding, be explained through the physicalist notion, like the experience of something.
Right. So yes. So some physicalists will say that physical systems with the right properties will give rise to conscious experiences. Others, like Dan Dennett, would say they give rise to the illusion of conscious experiences. As a hard-nosed scientist, uh, I want explanations of specific conscious experiences, right? So no one has put a gun to my friends and colleagues' heads to say you must come up with a physicalist framework and explain the taste of mint in that framework. No one, that they've chosen to do that, and they're making claims that there are causal structures that are identical to the taste of mint. For example, integrated information theory says there's a matrix. You can actually write down a Markov matrix. It's a square array of numbers, like it could be 10 rows and 10 columns, so it has 100 numbers in it, and each row is a probability measure, and that's going to give you your causal structure. So no nonsense, there's this mathematical model there, and that is, if it's the right causal structure, it will be the taste of mint or the smell of garlic or whatever it might be. So I didn't tell them to do that. I didn't say they had to do that. No one told them that they've chosen to do that. So as a scientist, I say, okay, well, so you're proposing that theory? So great, give me one. There's literally trillions of experiences that humans can have. Trillions. Should be like shooting fish in a barrel. Pick one. Pick any experience that you want to and give me your matrix. Tell me, if it's, is it 1,000 by 1,000? Is it 1,253 by 1,253? What's the principal reason for why it has to have that number of rows and columns? And then if it's like 1,000 by 1,000, well, there's a million numbers. 1,000 times 1,000 is a million. So there's a million numbers. And as a scientist, you need to tell me why each one of those million numbers is exactly the value it is, and why that's necessary for this to be the causal structure of mint. Again, I didn't tell you to do this. No one put a gun to your head. You're offering this theory. And I'm just being a hard-nosed scientist and saying, okay, that's your theory. Give me one. Give me a particular case. And I do this at conferences all the time. My buddies are up there, and they know I'm going to do it. And the answer in every case is they can't give one. There's trillions of experiences, and zero have been explained. Zero. And it's not because these people are dumb. They are brilliant. Some of them are geniuses. You can't construct conscious experiences from unconscious ingredients. Can't be done. Just that simple. And so that's 99% of the research in the cognitive neuroscience of consciousness is of this type. And here's why they do it. There are incredible neural correlates of conscious experiences. Anybody who studied in this area knows there's hundreds of well-known neural correlates of conscious experiences. I've studied them myself. It's a worthwhile area of study. I've been a participant in fMRI and EEG experiments and so forth. I'm not against it. I'm for it. I'm a co-author on some. It's good stuff. It's good to find correlates, neural correlates of conscious experiences. And we even find neural correlates where we can predict from your brain activity several seconds before you can tell me what you're going to experience or think or do. So I can actually beat you to the punch. So most people say that hands, case closed. Case closed. I mean, if I can read your neural activity ahead of time and know what you are going to do before you can tell me what you're going to do, clearly your brain caused it. Not at all. Absolutely not. Correlation, even prior activity, doesn't entail causation. It just doesn't. Roosters crow near sunrise, and they're highly correlated, and that doesn't mean that the rooster crows cause sunrise. Train station. You see a bunch of 100 people gather at a particular train station, and all of a sudden a train arrives. So just by looking at the people, there's lots of people gathering, I can predict, 10 minutes ahead of time, there's going to be a train coming, and I'm right. Does the train come because all the people are there? No. There's something deeper that you can't see. There's a schedule that's coordinating both the activity of the people and the activity of the train. That's the deeper thing that's going on here. So, and that's what I'm proposing is, there are these correlations, and sure, brain activity in many cases precedes the experience or precedes the action or even your knowledge of what you're going to do. And you can predict it from the brain. That absolutely in no way entails that brain activity even exists when it's not perceived. It doesn't. So, and I'm saying, think about, the train schedule. This is something that you didn't see. It's something, there's people and there's the train. What you're not seeing is this train schedule, which is different. It's deeper. And I'm saying there's something outside of space-time that's, if we're going to talk about causes and effects, I'm not even sure outside of space-time that we should do that. But if we're going to talk about causes and effects, it would be outside of space-time that we'd look for those causes.
So let's go a bit more into your modeling of conscious observers and Markov chains. What are those? How would you explain that to the layman?
Right. So, and I should put that in a context.
Yeah.
Right. So
why that way
why go after it this way? Because the idea that consciousness is fundamental is prior to space and time is not new, right? Spiritual traditions and idealist philosophies and so forth have, in some cases, said this for thousands of years. And it was those kinds of traditions that were sort of against science. Like the church imprisoned Galileo for heresy, for disregarding certain spiritual doctrines that they had. He had to recant some of his science. And so there's this long history between science and spiritual views that take consciousness as fundamental. And from the science point of view, we freed ourselves from the arrogant dogmatism of many of those traditions. And we said, let's do our own experiments. Forget authority. We don't care about authority. We want to do experiments, write down mathematical descriptions of what we see, and build our theories. And it works. Authority doesn't work. If you look at all the technologies that we have around here, cameras, watches, cell phones, how many of those were invented by spiritual traditions? Zero. How many were invented by physicalist science? All of them. So based on what works, you would say spirituality, there's no beef there. It hasn't produced anything. And the space-time view has produced science and all the technology. The church argued that their authority was based on lots of miracles. And they should be taken seriously because of all the miracles. Today, all the miracles are from science. I can talk to someone on the other side of the world right now by phone. To someone in 1850, that would have been indistinguishable from a miracle. And it's science. So when I say consciousness is fundamental, it's in this big context that we have to look at that. That was said for a long, long time. Science was the middle finger to that. Basically, it was saying, no, we're going to do something hard-nosed here. We're going to do experiments in space and time with physical stuff and look at, now we're the ones that have the miracles on our side. If you want authority, we have the miracles, not you. But now I'm saying it's time for us to step back and look at this whole thing. I'm not going back to the authority. I don't care less about authority. Couldn't care less. I think it was misused against Galileo, and I have no interest in it. But the idea that space-time isn't fundamental and that somehow consciousness might be fundamental, I think is worth pursuing. But we have to say from the get-go, that idea has given us absolutely no technology and no precise mathematics.
Which if it then somehow, through making this rigorous, does bear fruit, and technology will open up a whole new era, which we can get into. But I want to make our way through the Markov chains and
right. So that's now the Markov chains come up because here's the issue. We need our first theory of consciousness, qua consciousness, outside of space-time. That first theory that's mathematically precise and can make predictions about things in space-time. So there have been quasi-theories, like you might call them, but no theories that say, I start with consciousness with this mathematical model outside of space-time, show you exactly how it projects into space-time and make predictions that are testable inside space-time. There's nothing on the table. And if you, and so, I want to really be clear about this. I was hard-nosed about my physicalist colleagues and friends saying, how many conscious experiences you can explain? 0. Okay. And we're clear, you can explain 0. And you've been at this for decades now. Now let's turn it around. For the spiritual traditions, you've been at it for millennia, not just decades, you've been at it for millennia. How many of your theories can now explain Minkowski space and curved spacetime of Einstein and give us the standard model part? 0. There's nothing on the board. So both sides have nothing, literally nothing on the board in terms of starting with physics and booting up consciousness. There's nothing on the board. Starting with consciousness and booting up physics, there's nothing on the board. So that's the state of play. So what I'm trying to do now is to put something on the board. And I'm convinced that the physicalists can't do it. Not because I'm a cognitive scientist and I don't like physics. It's because the high-energy theoretical physicists tell us space-time is doomed. Okay, they're the expert, and I knew it anyway, because no theory is the final word. Space-time can't be the final word. That's just an assumption. And my theory is also going to have its own limits, but at least they'll be broader than the space-time limits. So I'm proposing that we can model consciousness with these things called Markov chains, and I'll explain just intuitively what that means. Very, very simple. I'll use a traffic light like I do in my little paper. Suppose you're sitting in your car waiting at a traffic light, and you're looking, because you have to pay attention, and it's red, of course. And you know that, so that's your experience. I'm seeing red, and a little bit, it turns green. And then if you're stupid and stay there for a while, it'll turn yellow and it'll turn red. So you get, with the traffic light, you can see there's 3 experiences you can have: red, green, and yellow. And there's also a sequence that you'll see. If I see red now, then if I can say, what will I see next, right? And so the next thing I'll see is green. And then if I see green now, the next thing I'll see is yellow. So I can write a little matrix. If red now, the probability is 0 that I'll see red next. Probability is 0 that I'll see yellow next, but probability is 1 that I'll see green next. And so for yellow, I can say, well, probability is 0, I'll see red next, and so forth. But probability is 1. Let's see. If it's yellow, then I will see red. I'm sorry. If it's yellow, I'll see red next, but I won't see green next, and so forth.
So there's a sequence of experiences and probabilities attached to those sequences.
That's it.
And you could take that traffic light analogy and now put it to the human experience, which doesn't just have 3 options, but trillions of experiences.
Trillions. That's right. So now go from 3. I did 3 to keep it simple, but you can just see about the transitions. But you have trillions of experiences. So now I'm going to model you with a pretty big matrix. It's a trillion by a trillion. That's a big number. I don't even know what a trillion squared is. It's a big number. So there's a trillion squared transition probabilities in this thing, and that's what I'm going to use to describe.
Is there inherent limitations there? Because would you say there is a fixed finite number of possible experiences on offer in human perception, or is it potentially infinite?
My guess is that our experiences in this particular headset of space and time are immense, but 0% of the total possible experiences that are outside of this headset. So I'm not sure if our experience in the headset is infinite or not, but even if it's infinite, it's 0% of the infinity beyond.
And a trillion by trillion is a big enough database.
That's enough
to get
for
some
my
work
work.
going. Yeah.
That's enough to challenge my little computer. Yeah. and so that's couldn't be simpler, right? I mean, it's basically saying it's very simple. You have experiences and they change. I'll just write down the probabilities that they change. So, of course, I'm not telling you what an experience is. I'm just saying I'm going to start with experiences. Instead of starting with space and time and physical objects and trying to explain experiences, which hasn't worked. We can't explain the taste of mint even. I'm going to say, okay, every theory starts with certain assumptions. My assumption is going to be experiences. That's where my explanation stops. Where do the experiences come from? I don't know. For the physicalist, where does space-time come from? I don't know, but I'm starting with space-time. Same here. I don't know where the conscious experiences come from, but that's where I'm starting, because no theory in science is ever the final theory. It makes assumptions. So yeah, is my theory not the final theory? Absolutely not. I'm starting with experiences, and I then, to be a good scientist, have to show where space-time comes from. So I have to get Minkowski space. I have to get Einstein's time dilations, right? If you're moving past me, I see your clock moving slow, but you see my clock moving slow. If we're in uniform motion, non-accelerated. And I also have to explain why your meter stick looks shorter to me and my meter stick looks shorter to you. So no one's come close to doing that kind of thing, starting with conscious experiences.
This is where trace logic comes in.
Now I can do this. I can do this. And this is something we've just discovered since the last time we talked. I didn't have this. I was looking at traces. So I have to tell you what the trace logic is, but I'll just say at top level where we're going. It turns out that there are ways of relating different observers by this notion of trace. And this relationship among observers that we can specify mathematically turns out to give us Einstein's time dilations and space contractions. And in a very nice, clean, quantitative way. I mean, not just a hand wave, but quantitatively, for a particular class of these Markov matrices. And then a larger class, I think, will give us the curved spacetimes. And those two classes together are 0% of the Markov matrices, which is all the rest of this universe I've been talking about that's outside of spacetime. And our headset sees 0% of it. But at least I can show you exactly, I'm proposing, how to get exactly Minkowski space and curved spacetime from this trace logic. So here's the idea of the trace logic. Let's go back to the traffic light. Keep it simple. Suppose I'm looking at the red, green, and yellow traffic light. And let's suppose it's a dysfunctional, sort of a messed up traffic light. So the probabilities aren't nice and clean. Red could stay red or it could go green or yellow and so forth. And suppose that you're looking, so I'm looking and you're looking, but you can only see red and yellow. I can see red, green, and yellow, but you can only see red and yellow. And suppose I'm going to take my matrix and add one thing to it. Every time I transition, my experience transitions from like maybe red goes to green or maybe red goes back to red. I mean, it's a transition from red to itself. I'm going to increment a counter each time a transition happens. So I've got a counter, and I'm seeing red, green, and yellow, and you and I are looking at the same light, but you only see red and yellow. You don't see the green. What's going to happen to your counter compared to my counter? Well, I'm going to be going a click every time red, green, or yellow appears. You're only going to click when red and yellow appear. So your clock is going to go slower than mine. It's that simple. It's just that simple. I'm proposing that time dilation in Einstein's theory comes from the fact that these are so-called enhanced Markov chains. They're enhanced in the sense that they're Markov chains with a counter. They're sometimes called spacetime chains. In technical books like Daniel Ravuz's Markov chains book, they're called spacetime Markov chains. But I'll call them enhanced chains. Your counter, if you only see red and yellow, will count fewer because you don't see the green. You only see red and yellow. I see the green, so I get a click for green, but you don't get a click. That's why your counter is going slower. Now, that's not quite deep enough because, as I said earlier, it's not just the case that your clock looks slower to me, but it's also the case that for you, my clock looks like it's going slower to you. So I gave a simple example. I have to give it just a slightly more complicated one to get the full Einstein thing. Suppose we have a light that has red, yellow, green, and blue. Okay. And you see red, yellow, green, and I see yellow, green, and blue. So I don't see red, you don't see blue. We both see yellow and green. Now, when I look at you, all I can see of you is you under my yellow, green, and blue looking, because that's all I see is yellow, green, and blue. You only see red, yellow, and green. So all of me that you can see is the yellow and green. That's all you can see of me. And all I can see of you is the yellow and green. So from my point of view, I'm getting clicks for every yellow, green, and blue, but you're only getting clicks for yellow and green. So your clock looks like it's going slower to me. But from your point of view, you're getting clicks for every red, yellow, and green. I'm only getting the yellow and green. So I'm going slower with respect to you. So we get the symmetry of Einstein. So it's, by the way, I had this trace logic for probably more than a year. I was working on it. And first I discovered that it was a logic. So that was apparently a new contribution to the theory of Markov chains. And I should say what that contribution is and what it means by the trace. If I have the red, yellow, and green, just the red, yellow, and green, and I can only see the red and yellow. Whatever probabilities were governing red, yellow, and green are now they're going to control. Now I just see red and yellow. So I'm going to get just a 2x2 matrix, right? Because red could go to red or red can go to yellow, yellow can go to yellow, yellow can go to red. So I'm going to get a 2x2 matrix of probabilities, but it will be controlled by the 3x3. There's some 3x3 matrix that's controlling the red, yellow, and green that you see. But it will uniquely determine what you should see on the 2x2. That's the trace. The smaller matrix that's determined by the bigger one is called the trace of the bigger one, and it's unique in general. So if I have a big Markov matrix on a trillion states, and I take a trace on 10, that new probabilities on just the 10 states will be completely determined by the trillion by trillion. But so what I discovered was, and I should say, I proposed this, and then a mathematician friend of mine, Chetan Prakash, proved it. So when I say I discovered it, I needed a real mathematician to truly discover it. So Chetan and I discovered it together. We proved that it's a so-called partial order, or he proved it. He proved that it's a partial order. I proposed it's a partial order. And so that's what we mean by a logic, is that technically it's a partial order. It gives you the notion of and or and negation and implication and so forth. All the things that you would need for a logic, like to say that if John is a bachelor, then John is a man, right? That's entailed by that. If, and things like that. If you could take conjunctions, disjunctions, and so forth, they're propositions. So it turns out we get an entire logic on the space of Markov chains. And so I call it the trace logic. And this is a new discovery. So we just discovered it in the last year. And I had it for a year and a half. And after it was a year later, I was looking at this. It was just a few months ago, maybe 6 months ago. I was looking at it, and I noticed what I just had described to you, that, oh, wow, at the stopping light, my one person's counter could be going slower than my counter, because of this trace thing. I thought, could Einstein's time dilations come out of that? That would be too good to be true. Well, and if that wouldn't be enough. I have to get Einstein's spatial contractions. The ruler sticks have to. So I said, well, okay, let's see if this is real. What notion of ruler stick can we get out of Markov chains? Right? Well, I've got a clock, so that's easy. What about the ruler stick? Well, it turns out. So I went and did some homework, and there's a ruler stick that was discovered in 2017, so just 8 years ago, published by Doyle and Snell, two mathematicians. And so if you have the states of a Markov chain, like the red, green, and yellow, you can talk about the distance between states as a function of how long does it take to get, on average, from the red, say, to the green, and back to the red. Now, if it's traffic lights, so you go, a good traffic light goes red, green, yellow, red, green, yellow, okay? And it's just in a cycle like that. It's a cycle. Then the commute time, the time it takes to get from red to, say, green and back again, is 3. Because you have to go, so I'm starting at red, one step to green, then to yellow, and then back to red. That's 3. And it's the commute time is the same. From green to yellow is 3. From yellow to red is 3. All of them are 3. So for an n cycle, if you have a cycle of n states, the commute time is n. And what Doyle and Snell proved is the commute time is the square of the distance. So the distance is the square root of the commute time, the Euclidean distance. And so I said, okay, so we actually now know what the notion of distance is. So does it work? I've got Einstein's time dilation, or time, slowing down of time. Do I get the rulers contracting? And they have to contract, by the way, in Einstein's theory, the same factor. The factor that is affecting the time has to be the same factor that's affecting the distance. It's called the Lorentz factor in special relativity. And the answer is the two factors for Markov chains are not the same for almost every matrix. 0% of the matrices have the right thing, but that 0% are the n cycles. So what we find then is I get the same quote-unquote Lorentz factor exactly as I'm supposed to for Einstein if I only look at Markov chains that are n cycles. You might say, well, that's not fair. I mean, you're just picking out the ones that work. Well, Einstein only used light to build the flat spacetime, only light. And he used the property that light has the same speed in all inertial frames. That's all he needed. He only needed light. So that then puts a new burden on me. I now have to say what mass means and what light means, because light is massless. So photons of light have no mass. And in Einstein's theory, anything that goes the speed of light has no mass. And if you have mass, you never travel the speed of light. That's just the way it is. Why? That's just the way it is. Again, the theories stop. So I have to have a theory now of what is the mass of a Markov chain. I also have to have the notion of its speed. So the commute time that I just talked about, which is the average time it takes to get, the expected time to get from one state to another, you can now ask for a Markov for all the states. What's the average commute time between all the states? And the average will be for an n cycle will be n. The commute time will be n. And it turns out that is the fastest commute time. That is the fastest. Any other Markov chain that's not an n cycle will have a longer time. So these are the fastest. So the one matrix that works for me to get Einstein's time dilations and length contractions to be exactly the same is the only matrix that is the fastest matrix in this commute time sense, the average commute time. And there's good reasons, and I can explain why, we can talk about something called the entropy rate of a Markov chain as the mass. So the idea about mass is something that's more massive is more influential. It interacts more with stuff, right? If you're close to, like if you're on Jupiter, you'd be sucked down much more hard than you're sucked down on Earth. And if you're on the moon, you can see the astronauts were jumping way up much higher than they could do on Earth. The moon was not as influential on
More gravitas.
More gravitas, absolutely. So the idea is there's some notion of influence that we needed to capture in Markov chains, and I'm proposing something called what's called the entropy rate. And entropy rate is a big important thing in information theory. It tells you how much you can compress data and so forth. So it's error correcting codes and data compression. Entropy rate is a big deal in this. So it's not a new idea of mine. This was like at the foundations of information theory. Entropy rate is like right there at the center. So it was not hard for me to look at it and go, well, that's probably the entropy rate, because the entropy rate is 0 for the n cycles. And so they have 0 mass. So I'll summarize it. I'm proposing that these cyclic matrices correspond to photons in spacetime. They project
because they have no mass.
They have no mass, and they're the fastest things.
Does that mean there's a correlation between light and conscious experience? Is that a stretch?
Well, this is conscious experience, and I'm proposing how the very structure of space-time is just a conscious experience. The Minkowski structure of space-time is literally coming from the structure of conscious experience and this trace logic entirely. And so entropy rate is projecting to mass. 0 entropy rate is projecting to 0 mass. The only things that have 0 entropy rate move at the speed of light. So what Einstein couldn't explain, he had to assume, I'm explaining. I'm saying that the reason massive objects cannot travel at the speed of light is because no matrix with positive entropy rate has a commute time as fast as the n cycles. They just don't. That's why. Why is the speed of light the same for all observers in all inertial frames? Because the trace of an n cycle is an n cycle. It's always the same speed, one state per step, one new state per step in an n cycle. So what Einstein has to assume, so Einstein has to assume that the speed of light is the same in all inertial frames, and I don't. I explain why it's the same. And why is there no preferred inertial frame? The answer is because in this trace logic of matrix, there's no top matrix. You can go to infinity in an infinite number of directions, and there's no top. So there's no special final inertial frame. So the bottom line is a theory of consciousness outside of space-time with these Markov matrices. Identify mass as the entropy rate. Identify the clock counter as projecting to time. Identify the commute times between states as projecting to distance. and you get Minkowski space coming out. Now, I've shown it qualitatively here. What we have to do now is to show with mathematical precision. I can take discrete Markov n cycles, maybe 3 of them, for example, interacting. And as n goes to infinity, I have to show that I can get probably using something called Lorentz, Gromov, Hausdorff techniques, prove that I get exactly the structure of Minkowski space. So that hasn't been proven, but we know
that's what you're working on now.
Yeah.
Okay.
We're working on that now. So, but what we do have is qualitatively, we get the space contraction, the time dilation, and they match. The interesting thing is, I mentioned that Doyle and his colleague that wrote the Doyle's paper on Markov chains, that the commute time is the square of the Euclidean distance. So the Euclidean distance has to be the square root. So to make things work, I need to also take the time counter, the counter of the conscious agents, and take its square root to get the time in space-time. So now you might say, well, that seems like a kludge. It's very interesting. In physics, there's something called charge parity time symmetry, CPT symmetry. And I think we're going to get that from the fact that when we take the square root, you can have either plus or minus. When I take the commute time and take the square root of it to get the distance, well, there's a plus distance and a minus distance. And when I take the time square root, again, there'll be a plus and minus time. I believe that will give us what's called CPT symmetry in physics, which has been shown empirically. So if this is right, then not only do I explain why the speed of light is the same in all inertial frames, why no massive object can ever travel at the speed of light, why no inertial frame is special, but also where CPT symmetry comes from. It comes from the fact that the conscious agent dynamics is not inside space-time, and we need to take square roots to get the space lengths and clock times that we see inside space-time. And it's that fact that gives us the CPT symmetry. So I should summarize what we have and what we don't. What we have is a trace logic that's secure. It's a new contribution to the theory of Markov chains. That trace logic for n cycles gives us exactly the right contractions of length and time for Minkowski space. For other matrices, those contractions will be different. The lengths and time contractions will be different. And for those, some of them I'm proposing, and this we haven't proved, that they will project to curved spacetimes because the lengths and times are different. They're not exactly the same, so you won't get flat spacetime, you'll get curved. I think that will be a larger class of matrices that work, but I think there'll still be 0% of all the matrices. And my guess is that almost all the matrices in consciousness space are too complicated. They'll have things like they'll have expander graphs and other weird properties to them that will preclude them from projecting into space-time. So space-time isn't the final reality. It's a trivial 0% of the new reality that's unfolding when we step outside of space-time and say, what's our simplest, most drop-dead, stupid model of consciousness we can come up with? That's what I came up with, the stupidest, drop-dead simple model. You have experiences, and they change probabilistically. Okay, what can we do with that? Doesn't sound very promising, right? Going to get all of space-time physics out of that? Small chance. And that was until I discovered the trace logic. And then all of a sudden, in the last 6 months, I realized, holy smoke, it could be this simple. It's really, what is the trace logic? It's saying how the experiences of different observers mesh. That's what it's about. It's all about observers and their experiences. There's an infinite class of observers, and we can talk about their time counters, and observers that see smaller set of states than me, their time counter is going to go slower than mine, and so forth.
Hey fam, one thing that brings me a lot of joy is having a warm, nourishing drink to start my day, but I don't drink coffee, and that's why I love MUDWTR. Their original blend is a coffee alternative made with 4 functional mushrooms, so you get natural energy and focus, but with just a fraction of the caffeine in coffee. There's no jitters, no crash. They've also got a matcha blend and 2 caffeine-free blends, Rest and Gold. Rest is perfect for winding down at night, and Gold is a turmeric blend with ashwagandha and chamomile, which helps you chill out in the evenings. After a long day, I like to add a little bit of honey in their coconut creamer, and it's like a sweet treat that makes your body feel good. Every ingredient is 100% organic, non-GMO, gluten-free, sugar-free, and vegan, so you're putting good stuff in your body. If you want to give them a try, head to mudwater.com/knowthyself to grab your starter kit. Right now, our community gets up to 43% off your entire order, plus a free rechargeable frother and free shipping. That's MUDWTR.com/knowthyself. Link in bio as always. I hope you dig it. Hey guys, a quick one. One of the hidden challenges of modern life is mineral depletion. Our soil is not as nutrient rich as it once was. It's invisible, and yet it affects us so much so. A lot of us are running on empty without even knowing it. The result is impaired immune function, fatigue, muscle weakness, cognitive issues, and so much more. That's where shilajit comes in. Shilajit is a nutrient-dense resin containing a wide spectrum of over 84 essential minerals, humic acid, and fulvic acid to help restore balance and replenish what your body is missing. Supplementing with it throughout your week can immediately support those depletions. Looks like this. You can just take it directly or put it in some liquid or a beverage of your choice. Fractal Forest is the company. They are a research collective restoring meaningful connection between humanity and the earth. They only source gold-grade, triple refined and filtered shilajit from the purest of places, so the quality is the best that you can get. They're giving up to 40% off with subscription on any of their products, or just try it out for free with a 10 milliliter bottle. Just pay shipping. You can go to fractalforest.co/knowthyself or use code knowthyself at checkout to get your shilajit today. I hope you enjoy. Back to the episode. I want to try to explain this back to you to see if I actually understand it. Okay. Or at least an aspect of it. Because I think whenever I'm preparing for something, especially something that can get pretty rigorous in the scientific side, I try to write it out to be able to explain it to myself and see if I actually understand it. So quantum mechanics says that particles are described by wave functions.
Yes.
Probability waves that evolve smoothly but collapse when measured. And so your point basically is that if you look at the long-term dynamics of these Markov chains instead of the step-by-step transitions, the math looks identical to quantum wave functions.
Right, and that's something I haven't talked about yet here.
Okay, right. But so in other words, quantum theory is what you see when you zoom out on the probabilistic flow of conscious experiences. So quantum states aren't fundamental. They're the shadow of deeper dynamics of consciousness.
Right.
I know you kind of alluded to it a little bit earlier, but haven't spoken directly to the kind of correlation there between the two.
Yeah, I should say a little bit about that. So what I've done so far is to talk about how a theory of consciousness with these Markov chains and the trace logic could give rise to the structure of Einstein's Minkowski space-time. But of course, quantum theory is extremely important. And so how does that come out of this, right? And so here's the remarkable thing that my collaborator, Chetan Prakash, discovered about 10 years ago or so. If you look at, I've been talking about the step-by-step Markov chain.
Yeah.
If it's red now at the light, and then maybe it'll turn green next, and then yellow, and so forth. That's step-by-step.
But then when you zoom out,
if you step back, that's sort of like looking at a movie one frame at a time. But if you step back and you try to look at the whole movie in real time, you get a different picture. And when we look at Markov chains, not step by step, we look back at the big picture of what's happening in the dynamics of the Markov chain, the big movie. We call that the way you do that is you compute what are called the harmonic functions of these enhanced chains. So you compute the harmonic functions, and they tell you the long-term behavior, these harmonic functions. And what Chaitan discovered is these harmonic functions are exactly the same mathematical functions as quantum wave functions for free particles. So the quantum wave functions for free particles and the harmonic functions of the Markov chains that we're looking at are the same thing.
What does that mean?
So it means that we're proposing that spacetime is constructed just by the end cycles of Markov chains in the way I just described. And quantum wave functions are describing not the detailed dynamics of conscious experiences. They're giving just the top level picture of it, not the step by step. We have, in other words, in this consciousness framework, I'm telling you every step of the way what's going on. And in the space-time headset, quantum mechanics just says, well, you don't need to look at all those details. Here's just what's happening long term. Mm-hmm. You only get to see the big long-term picture. I'm showing you that what's are called the hidden variables. This is what's called a hidden variables theory of quantum mechanics. Okay, so these hidden variables are things that you don't see inside space-time. They're hidden to quantum mechanics. Quantum mechanics doesn't describe them, but they're right there in the harmonic functions of the Markov chains. And what's interesting about the harmonic functions, right? Everything is real. All the numbers are real in my Markov chains. All the probabilities are real and so forth. But when you take these harmonic functions, you get complex numbers as part of taking the harmonic function. So where does all the weirdness of complex amplitudes come from? It's because you're not looking at the full reality. You're getting the top level gloss harmonic functions, and those use complex numbers to describe the long-term behavior of it. So we get space-time and quantum theory coming out. Now, I'm saying this at top level. I already said a theorem that we need to prove about space-time, right? So we have to prove that the Lorentz, Gromov, Hausdorff convergence works from end cycles to Minkowski space. And then we have to prove that the similar kind of convergence will work for curved space-time for a slightly larger class of matrices. And then we need to show, for example, well, two things. First, why we're not violating Bell's theorem. So there's something called Bell's theorem, which says there aren't any hidden variables theory, roughly. So here I am not saying I've got a hidden variables theory of quantum mechanics. Most people in the know would say, well, John Bell proved that there aren't any, so you're off your rocker. What John Bell proved was that there were no hidden variables theories that were measurement independent, local, and deterministic. But our theory is not measurement independent. In fact, it's observers. If anything's measurement dependent, they're observers. So we have a measurement dependent system. It's probabilistic, and it's not deterministic. John Bell's theorem is true, and it doesn't apply to us because we're non-local, we're not deterministic, and we're measurement dependent. So Bell's theorem is true, and it doesn't rule out our hidden variables theory at all. So we now have to prove. So that part's clear, but now what we have to prove is there's something called the Born rule in quantum theory. The Born rule says if you have this quantum complex amplitude, the wave function, you have to take the amplitude squared to find out the probability of various outcomes occurring. That's a very famous Born rule. So I've done a little work on it, and I think it's going to be true. But until you prove it, but I'll put it this way. I see no obstruction at all. I see no obstruction to getting curved spacetime. I see no obstruction to getting the Born rule. But these are very, very technical mathematical issues. And so until we have it, we can only, so I won't promise more than I can say right now. What we do have is The trace logic is real. That's not going away. The time dilation space contraction for the n cycles, that's not going away. That'll be there. The claim that will give rise specifically to Minkowski space, we know the theorem that needs to be proven, and we haven't proven it yet, but I don't see any obstructions. But again, I'm just a cognitive scientist, so this is real math, so we'll see. I don't see any obstructions right now, but we may need some really hard-nosed technical mathematical physicists to bring this stuff home. So it's just been in the last few weeks that I've even known that these are the theorems we need to prove. So this is brand new. This is the first time I've actually talked about this.
It's exciting.
Yeah, it's pretty exciting.
It is exciting, and I know probably aspects of it can definitely go over many people's head. I know for different parts, it does for me. Like there's a lot to digest there, but the spark notes, correct me if I'm wrong, is that if the bedrock of modern physics and relativity and quantum theory can naturally fall out of this theory or this model of conscious observers, then it kind of reverses the chain of causality of what we think consciousness is coming out of matter. Rather, it's the other way around.
That's exactly right, and this is something that the physicist John Wheeler was pointing to. So you got it right.
Okay, good.
And John Wheeler was pointing in this direction. He had a paper in 1989 that's called the It from Bit paper, but he was basically saying somehow it's got to be, from his point of view, all these observer participancy interactions has to be the fundamental thing. And somehow he said that has to give rise to the structure of space-time and quantum theory. He didn't know how, but he just felt like we can't start inside space-time. We have to start with the observer participancy thing. And so the reason he's taken seriously is, I mean, he was like the advisor for Richard Feynman, and he himself was an incredible physicist on his own right. So, and he, in his It from Bit paper, Wheeler cited, I mean, I should say, I've been working on this stuff for a long time, almost 40 years. So, I mean, it's not like I decided to work on consciousness outside of space-time. I've been working on it since
89?
85. So it's been literally 40 years.
Wow.
1985. And in 1989, I published a book with two mathematicians called Observer Mechanics. So, you can see I was already, I've been, this is not like a new gig for me. And Wheeler cited my book. So in his It from Bit paper, he cites my book as the example of the kind of thing that we might try to do in this observer participancy kind of thing. And I read Wheeler's paper, of course, and I agree with him, and we tried to get into the observer mechanics, but we didn't have the trace logic. And I didn't have the trace logic until a year and a half ago. And I didn't know what I had until 6 months ago. So I've been after this for 40 years, and just 6 months ago, I think I found the key that I've been looking for 40 years. And it's also what the kind of thing that Frank Wilczek was saying, is we need to have some notion of the observer as a foundational concept. So what I'm saying is that Wheeler was right. It's all these acts of observer participancy that somehow build space-time, and the thing that coordinates them is the trace logic. It's the trace logic, which is just the coordination of how your experiences and my experience are, how your clock is related to my clock, how the distances between your experiences are related to the distances in my experiences. The trace logic does all of that, and when we compress it down, we get space-time. So physics, from this point of view, the space-time physics is nothing but a beautiful way of coordinating all the experiences of the observers. So it changes the whole thing around.
Yeah.
We thought of ourselves in science for the last 4 centuries as little tiny physical objects in an immense physical universe whose consciousness emerged from unconscious ingredients. And this is turning the whole picture around. Space-time is not fundamental. We know that. It falls apart at the Planck scale. It can't be fundamental. That picture can't be right. But Wheeler's picture is a deeper picture. Observer participancy outside of space-time gets somehow fashioned into the structure that we call space-time. But it's the consciousness that's first. It's fundamental, and it gives rise to what we call space-time. And it's the trace logic. And by the way, the trace logic is not hard. I could have thought about it 40 years ago. I just didn't think about it. It's not that hard. I don't know why it took me 40 years. I'm not that bright.
Do you remember the moment that came to you? You said you were in a car,
yeah.
or
I think I was at home, and one problem that we've been working on is how do observers, or what we call conscious agents, but we'll call them observers, how do they combine? And I've, Chetan Prakash and Robert Prentner, two really good, brilliant friends of mine, longtime collaborators, and they had been debating back and forth about a new way of combination. And I looked at what they were saying, and I just looked at, and it felt wrong. But when I felt that it was wrong, I also felt, here's why it's wrong. And all of a sudden, I saw the trace logic. It was in reaction to the trying to figure out how to combine observers and seeing their ideas, seeing that I disagreed with those ideas, and asking myself, why do I disagree with those ideas? And that's when I saw the trace logic structure. All of a sudden, I just saw it. So because in the trace logic, it turns out it gives you a way to join two consciousnesses into a single new conscious observer. And so it was that problem. How do I take two separate consciousnesses that maybe overlap? Maybe we have some similar conscious experiences, but how do we join them together into a coherent new observer? The trace logic does that. It tells you exactly what that join means. So it's something I didn't talk about. This is actually, in terms of the theory of consciousness, this is also a breakthrough. It's a breakthrough that says, if you have two consciousnesses that do overlap, what is the unique, bigger consciousness that could be made out of them that traces down properly to each of the two separate consciousnesses?
An infinite shared space or source, which is the origin of shared experience.
Well, so these are prior to that. So the source is deeper than that. But what you're talking about, the source is even deeper. This was just a step up on the trace logic itself.
Yeah.
So how do I go from two consciousnesses, two Markov chains, to a slightly bigger Markov chain that properly contracts down to the two? So it's very much like the way I think about it. You have two hemispheres in your brain, a left and a right. And there are some experiments which have been done with split brain patients. So people who had problems with epilepsy that couldn't be cured or controlled with drugs. There were surgeries done where you would take off the top of the skull, take a knife. The guys who did this was a guy named Joe Bogan, one of the surgeons. I actually was friends with him. We would meet periodically at the UCI and talk consciousness and so forth. But Joe Bogan would take a scalpel and cut the corpus callosum, which is so you have two hemispheres. There's an Ethernet cable between them, connecting them, and he cut that cable, part of it or all of it, depending on the patient. And what they found was the two hemispheres now had their biggest connection was severed. There are some smaller connections, but the biggest connection was severed. And Michael Gazzaniga and others then did some experiments on these patients and found that they wanted to know what's going on. What does this connection do, and what happens when you separate the hemispheres? And early experiments couldn't find anything different about these people. So some people thought, well, the only thing the corpus callosum does is put epileptic seizures from one hemisphere to the other. That's all it's good for. Well, no, of course that's not the case. So what Gazzaniga found was that he could isolate information to the hemispheres. It turns out that the right hemisphere only sees the left visual field, left hemisphere sees only the right visual field. and the left hemisphere gets input from the right side of the body. The right hemisphere gets input from the left side of the body. So if you give information to just the left visual field quickly, before you can do an eye movement, you can send something just to the left visual field and only the right hemisphere sees it. Or put something in the right visual field, only the left hemisphere sees it. But if it's on there for more than 1/10 of a second, then you'll get an eye movement and both hemispheres will see it. So that's why they couldn't figure it out before. People were doing eye movements and both hemispheres got the information. So, but Gazzaniga learned to, and Roger Sperry. So I should, Sperry won the Nobel Prize for this. So it would be,
We just had Ian McGilchrist in here too. We were actually speaking about this.
Okay, very, very good. Yeah. So what you find is that the two hemispheres have very different personalities in some cases. In one case, the left hemisphere wanted to have a desk job, and the right hemisphere wanted to be a race car driver. The left hemisphere believes in God, the right hemisphere is an atheist, or vice versa. So here's the notion of join now. So I said all that for this trace join. Somehow you have two hemispheres which, if we cut the corpus callosum, show that there are different personalities with different religious beliefs, different job aspirations. They're different. It seems like maybe part of the human condition is we're born with two. You're not just one person, you're two people. And what you are learning to do in this body is join them. How do I create the join?
The two becoming one.
Two becoming one and cooperating. And for a lot of us, it's not an easy process. I get pissed off at myself. And what are you doing that for? Yeah. You can imagine, actually, in some of these with the corpus callosum cut, the hands fight each other. The left hand and the right hand fight. So that's in all of us. So this join of the trace logic, I was after it because I understood Roger Sperry's work and Joe Bogan. I mean, I knew Joe Bogan personally. We're friends. I knew all this stuff. It's very clear that there's some kind of separate persons' consciousnesses that are being integrated, and the corpus callosum is not the whole story, but it's the physical aspect of it. And so I was after that join in the trace logic because I knew that would be the key thing. If this was going to work, it would be that to give us our first principled theory of how separate consciousnesses can join together. Because this has been a big problem in consciousness first theories. It's the combination problem. And if you look it up, if you just Google the combination problem in panpsychist theories of consciousness, you'll see there's a big literature. And basically, it's like can't be done. Now, panpsychist theories are very different from my theory.
What is the combination problem for people that don't know?
So the combination problem is how if I have two separate consciousnesses, can they be combined into a single consciousness? Can the subjects of experience be combined? And can the experiences themselves be combined? So there's the subject combination problem and the experience combination problem. And they're very, it's an ancient problem. The received opinion was that this is going to be difficult, if not impossible, to combine the different experiences. So I knew that's been out there for a long time. Everybody says can't be done, and certainly you can't combine subjects of experience. The very famous psychologist William James, in his Principles of Psychology, has a very famous paragraph in there about you can't combine the subjects of experience. If you have 10 different people or 100 different people, how are you going to combine them? You can tell them all the same thing, but it's going to be 100 different people thinking the same thing. Not the subjects don't combine. So I was, this has been a longstanding problem. And I was hoping that somehow this theory of, conscious agents with the Markov stuff would give me some tools for understanding how consciousness could combine, because it seems like that's going on there. The corpus callosum seems to be something that's mediating that in the case of our two hemispheres. And so you can see why I was going after this notion of join. But I didn't have a principled way of coming at the join. And it was the
trace logic is where that comes in.
And the trace logic, all of a sudden, by seeing this partial order, this logic, it automatically has a join, and that solves the problem. But what I had to do was step back and see the bigger picture and see there's a whole logic. So don't just think about the join, think about an entire logic on the space of consciousnesses. And when you see the whole logic on it, then the join falls out. And so it was that insight. And so what is the logic? Is the trace a partial order? Being a trace, is that a partial order? And I could immediately see there's three things you have to have for a partial order. It has to be reflexive, symmetric, and transitive. And I could see the first two, but I couldn't see the transitive. It looked to me like it was going to be transitive as well. So I could see two out of the three right away. I said, oh, yeah. And the third one looked really, I mean, it looked pretty secure to me. But, math is math. So I said it, I told my longtime collaborator, Chetan. We have collaborated about 40 years. So we're good friends. I said, Chetan, I think I've found this logic, that I think the trace is a logic on the space of all Markov chains. And he said, Don, it's too pretty. It can't be true. It's just too pretty. And he was taking off for a conference in England. So he flew. But when he landed in Heathrow, he said, oh, well, I'll give it a shot. And there in Heathrow, he proved it. He proved the transitivity. And then we knew we had a logic. And then but it took me almost a year to see, okay, because I was focused on the join and combination problem and that stuff. And so I was really pretty happy. I thought I'd gotten everything out of it that I possibly could. And I was very, very happy. But just one day I noticed, well, wait, the counter is going to click fewer times on the trace than on the bigger one. I couldn't get space-time out of this. No way. But I decided to check it out. And it's been a 6-month fun ride. I can't believe it. So I didn't expect to get space-time. I was just trying to get the combination problem.
Yeah.
And length contractions and time contractions, unbelievable. I can't believe I got it.
You just ordered a single meal and the whole buffet came with it.
It came with it. And then the fact that it was the square, that the commute times are the square of the distances.
It must be there.
It's amazing.
A good sign that there's an inherent simplicity, I suppose, or beauty to something that is coherent. So like there is not maybe not always the case, but throughout many different innovations and discoveries in the past, there is an inherent beauty to the simplicity of the discovery, which seems almost like too good to be true at first.
I couldn't agree more. And what's really interesting about the trace logic is there's no wiggle room. It's fixed. I can't play with it. It either worked or it didn't. So I knew I was either going to get Einstein's theory or not. There was no way for me to fiddle this thing because the trace logic can't be fiddled with. That's the trace is the trace. End of story. So it either did it or not. So it was too good to be true. I couldn't believe that it worked. So, yeah. Assigning physical interpretations of properties of the matrix there's no place really to fudge there. Commute times are commute times. That's, you can't fudge. Entropy rate is entropy rate. To say, if you ask what are the properties that could be mass, entropy rate is it. And so it either worked or it didn't. If the entropy rate being 0 didn't correspond to the matrices that moved fastest, then it would be game over for me. The whole thing would be over. So right now, there's no room to fudge at all in any of this, which makes me feel very, very comfortable because it will either completely unravel and we'll see the one thread that doesn't work and the whole thing unravels, or the thing is really going to take off. I'm hoping it takes off, and it looks like it's taking off because at every step I've said, okay, this has to be true or the whole thing won't work. Let me get check. It is true. Unbelievable. I've been surprised time and again that it's worked. So even as Chaitan said, he thought the whole thing was too beautiful to be true.
Yeah.
So we both thought at every step, this is too pretty to be true. This is, the party's going to be over, and we haven't seen the party over yet. So, but the fact is, it can't be fudged. So if the party's over, it will show us the party's over.
Which is the reward of the scientific mind, to go after disproving things that you would like to be true, to make it rigorous, right? And
Absolutely. And of course, what I said earlier about all scientific theories applies to my theory.
Yeah.
There's going to be a limited scope for this theory of conscious agents and the trace logic. But all I'm trying to do right now is to show that the scope is bigger than space-time, and the scope includes space-time, that we can actually build space-time from the trace logic of conscious. So I'm not saying that this is a final theory of everything. No, I will be very clear. This is 0% of reality. My theory is 0% of reality, but it's a bigger 0% than space-time. And if I can show how space-time is a smaller 0% than my bigger 0% of reality, that's a step. Science will always and only know 0% of reality. Always and only. But we should do it.
for many reasons we'll continue to get into. Now, what is minimizing surprise and how it comes into all of this for people that have like zero context of what that means?
Right. So the idea of minimizing surprise is quite big now in cognitive neuroscience and elsewhere. Carl Friston and his collaborators are using it, and it's related to intelligence in the following way. I mean, I'm not going to say it's all there is to intelligence, but it's an important aspect of intelligence. If every time I did something, I was surprised, like every time I went to pick up this cup, it fell down and crashed. Every time I put on a shirt, I ripped a hole in it. Every time I walked up the stairs, I fell on my face. Well, to the extent that I'm surprised, I'm not very smart. So in some sense, the more surprised you are, the less intelligent you are. Now again, I'm not at all saying that's the only aspect of intelligence, but it is, intelligence is not less than no surprise or minimal surprise. Now, suppose I have a big Markov matrix. Well, I'll just say the bottom line. Trace minimizes surprise. So the trace logic is the logic of minimizing surprise. When you have a probabilistic situation, you don't know what's going to happen, and all you can do is write down a Markov dynamics of it. And then if you have limited information, I can only see these set of states. I can't see the whole traffic light. I can only see red and green or whatever. But I want to minimize surprise. The trace is the minimal surprise answer. So the trace logic is the logic of minimizing surprise. And in that sense, it is the logic of intelligence. So now there are new companies working to go past large language models of artificial intelligence. I'm using the free energy principle to minimizing free energy to minimize surprise. What they really want to do is minimize surprise, but they can't do it directly, so they minimize free energy. The trace logic does it directly. It tells you exactly what the answer is. You give me any context, and you give me a subset of variables, the trace is the minimum surprise answer. If you want to take two probabilistic systems, you know both probabilistic systems, and you want to know what's the minimal surprise system that includes them both, it's the join of the trace logic, the disjunction of the trace logic. So it is the logic of surprise. So I didn't know this at first. I was only thinking about just consciousness combining and trying to solve the combination problem. Then I was interested in, wow, maybe space-time comes out of it, because of the changing clocks. But then more recently, I've realized, no, this minimizes surprise. This is actually logic of intelligence. So it could actually be of value technologically to be a core mathematical principle behind a new generation of artificial intelligences, which would be great fun for me because, as I mentioned to you, I was in the AI lab at MIT from 1979 to 1983. Took class with Marvin Minsky, worked with Bertold Horn and David Marr and Eric Grimson and Ellen Hildreth. I mean, I'm friends with all the pioneers in the early AI, computational vision work there, and John Hollerbach. So it's a real love of mine, the artificial intelligence, and to have the trace logic actually be a logic of intelligence blows my mind as well. So once I worked on the consciousness side of things, I may want to switch over and look at the AI side of it as well.
Yeah, so much to explore there as well. I'm curious because it's been alluded to throughout the conversation about when we're talking about the experience of a conscious observer. As a human being, we have this experience, which to agree there is an overlap in what we think your experience is. And I'm curious how you think of, as you introduced in your essay that you sent me, this sense of infinite shared space or the source in which our experience is derived. What do you make of that source in which experience is derived from?
That's a good question. So when you write down a Markov chain, like for the red, green, yellow traffic light, you mathematically, before you can write down the matrix, you have to specify what we call a measurable space. This is a mathematical name, but all it means is you need to tell me what states are going to be in your Markov chain, like red, green, and yellow. So you have to say there are 3 states and they're red, green, and yellow. And then you have to put a structure they called an algebra on them. But basically, so it's a measurable space. You list the states and you put some kind of structure on them. Now, if you have 5 states, then you need to have, if it's red, green, yellow, blue, orange light, then you need to have 5 states in a bigger measurable space. In the trace logic, if you're going to think about all these matrices in the context of the trace logic, then they can't each have their own little measurable space because you have to be able to relate all of them together. So you need a big measurable space in which they're all on. So effectively an infinite measurable space. So I need to write down an infinite measurable space of all possible conscious experiences with its own sigma algebra, which is the logic, the structure on it. So I can't just write down 3. It's infinite. And it's the same for all observers. All these different traces are all different observers. So the logic itself forces me. It says, Don, you cannot just talk about a 3-state measurable space and then a 10-state. You have to put them all on one. They're all derived from one big measurable structure. Now, so this is the mathematics forcing. So just a couple of weeks ago, I said, okay, so what is the mathematics trying to tell me here? I mean, so I've been working on the matrices and the transitions. I'm studying that. I'm getting space-time dilations and so forth coming out of it. But what about this deeper structure? It's just sitting there. It's timeless. It's there for every different observer, and in some sense, all the experiences are popping out of this deep structure.
Sounds very mystical.
It sounds very schmystical to me. I was like, but it's math. I have to write it down. I'm forced to write it down. And so I'm forced to ask myself, what's my interpretation of this? I've got my interpretation of the states and their transitions, their experiences and changing experiences. What is this structure that's timeless, from which, in some sense, all these experiences are coming out of? And the answer is, I don't know. This is where my understanding stops. So I just call it source, because it's the source of all the experiences. But it's a timeless source, and it's the same for all observers. And it's the foundation from which all observers, all traces spring. So then I agree. Then at that point, I thought, wait a minute, that does sound quite mystical and very much like what mystics have been saying for thousands of years, that we're all derived from one source, and in some sense we're just different emanations, they would say, from the source. I would say we're different headsets that the source has put on. The different traces are different headsets by which the source looks at itself. So that's the way I'm thinking about it now, is that there is this source. I can't say anything more about it than that, except what the mathematics says right now, which is it's the same for all observers. So Andre and Don are from the same source, just different headsets. It's the source talking to the source through Andre and Don headsets. And I can't say anything more about the source. I can say, we can write down a measurable structure for it. There's a sigma algebra, so I can say all that stuff. But that's the limits of my theory. Every theory has limits. There we go. The other limits are my probabilities. When you see a probability in a theory, that's where the explanation stops. Because probability is where I can't say anything more. I'll write down a probability measure. So my theory has the limits right there in our face. But the limit points right where the spiritual traditions have pointed, saying that there is some source, and they will say it transcends any description. You can point to it with words, but as the Tao Te Ching says, the Tao that can be spoken of is not the true Tao. And that the same is true of science. The science can point to it, and we can describe perspectives on it. So, for example, space-time perspective, that particular headset, our mathematical descriptions can be more or less accurate descriptions of that particular projection or trace of the one source. So it's not the case that everything is equal and my theory, earth, air, fire, and water is just as good as the standard model of particles. No, not at all. In a headset, certain theories are better and certain theories are worse, provably. So the science is right to be really hard-nosed about the theories. Absolutely. Most theories are going to be wrong about our headset. But when we go outside the headset, it's going to be, again, just a broader headset that we're looking at. So again, it'll be more true or false, but ultimately know that all of our theories, even our best hard-nosed theories, are 0% of reality. But at least we want to get that 0% right. And most theories are not even right about that 0%. So that's why most non-scientific theories aren't worth the time. Science gets 0%, but it gets it right.
Yeah. I'm curious how you would describe what I've heard you explain of infinite infinities. If there's a potentially infinite amount of available experiences, that means that there would then be an infinite amount of conscious observers. So what does that point to about the scope of reality beyond the headset?
It's the headset, our space-time headset. We think of space-time as the final reality. No, it's 0%. It's literally 0% of reality. And in the Markov dynamics that I'm looking at, it's 0. I can say what 0% corresponds to Minkowski space. I'm looking to be able to say what slightly larger 0% corresponds to curved spacetimes. And then the 99.99999% of it, basically 100% of it, will be beyond anything that could be actually presented in space and time. Again, partly for technical reasons, like, again, expander graphs for the Markov chains as opposed, things that wouldn't work well for general relativity. But the interesting thing is, spiritual traditions have been saying this for thousands of years. But now we have a new mathematical framework where we can say, at least for one step out of the space-time headset, here is a description of the infinities. These Markov chains that don't project into space-time, even curved space-time, they don't project. This is a first model to explore of the kinds of infinities of possibilities outside of our space-time headset. Before, all we could say in the spiritual traditions was, it's beyond what you can see of in space and time. All of a sudden, now we have a mathematical model that says, well, I'm not the final reality either, but here is a way that we can talk about the next step outside of the headset, and there's an infinite number of new things to explore here. So there's plenty to explore, and that infinite number of new things to explore here is 0% of reality, but it's infinitely bigger than the 0% that we had now. So we've just expanded to an infinitely larger space that's 0% of the final reality, and that's the way science will always progress. If it progresses.
What this really makes me think of is, if you look on the planet right now, we very much so have medieval minds and modern tools. We have
Mm-hmm.
uh, increasingly exponential technologies that, in a time where we face this meta crisis, where we could, the wisdom to hold those tools is not to the same degree we have in what these tools can do. You look from bioweapons to AI to, you know, all over the place. We need a radical transformation in consciousness and change in paradigm. And it seems like the way that could effectively happen is by these deeper understandings becoming self-evident by the scientific method and them becoming rigorous. If you are able to effectively prove to the analytical mind that we have this shared space, that we are one consciousness, a
Right.
lot of the what we've been exploring today, that to me changes the scientific paradigm and prevalent notion of what reality is, like on a widespread scale, to where it feels like the one of the, if not the only saving graces in the coming decades, where if something like discoveries like this don't come at this time, humanity very much so is in a position where we could go extinct. So that's, I just feel like the immensity of it. It rarely happens on this podcast where I'm having a conversation around something to somebody who's at the leading forefront of a discovery that I feel like truly can be completely world changing. So yeah, it just feels like, I feel like both the beauty and the weight of conversations like this.
Yeah, I think that's an important point about this, and that is that if the spiritual traditions have said for a long, long time that we all are from the one, but there's been no beef, right? Because as we talked about before, it gives us no technology. The physicalist framework gives us all the technology. It gives us all the miracles. No miracles are, uncontested miracles are coming from the spiritual side. So it's easy for people to dismiss we're all one and you should love your neighbor as yourself and so forth, because it doesn't work. It doesn't give us technology. And so you're just a physical system. Your consciousness emerges from your brain somehow. And when your brain is destroyed, you're gone. And you and I are definitely not connected. We're just separate bits of matter. That whole framework changes if we have a theory of consciousness that actually transcends what physicalist science can do. Then all of a sudden, now the smart money is no longer on physicalist reductionist kinds of views. If the new technology and the new deeper scientific theory shows that space-time is not fundamental, and it has this, like with the trace logic, this clean implication that there's one source, and it just falls right out of the mathematics. There's, again, no hand wave, and that one mathematical structure actually, if it, and again, I haven't proven it, but if it does give us Minkowski space and curved space-time and so forth, the Born rule and these things I talked about, then all of a sudden it changes the game. Now the smart money is on, yeah, you and I are one. I should love my neighbor as myself because my neighbor is myself just looking at me. So whatever I do to you, I'm really doing to myself. And now the best science says that. The best science does not say you're just a lump of atoms that happens to have some consciousness and you're competing with me for resources and I can do whatever I want to you because you're nothing. You're just a pack of neurons. I was good friends with Francis Crick. He was a wonderful man. I had lots of time with him and enjoyed talking with him. But in his book, The Astonishing Hypothesis, says you're nothing but a pack of neurons. And of course, he was a gentleman. He didn't treat people as a pack of neurons. But a science that says you're just a pack of neurons will lead a lot of people to have more
Exploitative ways of,
yeah, it can lead them. And again, I'm not saying that Francis was that way, of course, or any of these, any of my colleagues. So my colleagues are wonderful people. They're brilliant, hardworking, and moral, and so forth. They're wonderful. But I'm just saying, what does the philosophy itself entail? They've risen above the philosophy that physicalism entails. But if now all of a sudden the new miracles are coming really from a theory beyond space-time, if we can actually get new technology outside of space-time and a theory that actually works outside of space-time, then all of a sudden it's no longer just some airy-fairy mystical stuff to say,
Yeah.
you're all one. It's now the burden of proof is on the person who wants to say, no, we're not all one.
Can you speculate then what would be some of the most impactful innovations from discoveries outside of space-time? It seems like in so many ways you're taking stuff straight out of sci-fi films.
Yeah, it blows my mind what the possibilities are. But the one way to think about it is to, again, think about the Grand Theft Auto example. I suppose you're a wizard at Grand Theft Auto. You've done it for years and you're the best in the world. You can drive your car faster than anybody. You can do all the tricks inside the game. That's quite an accomplishment. But if I'm the geek who wrote the code for Grand Theft Auto, I'm not stuck inside the rules of Grand Theft Auto. I make the rules of Grand Theft Auto and I can play with them. And I can take the gas tank of the wizard and empty it. I can give him a flat tire, or I can make his car move from point A to point B without going through the space. I can just transport it not through space, but effectively around the space. I can do miracles vis-a-vis the person inside Grand Theft Auto. What I can do is miraculous because I'm not inside Grand Theft Auto space. I'm creating it. So as soon as we're not inside space-time, the technologies, once we understand how to work with technologies outside of space-time, it's like being able to write the code of Grand Theft Auto outside of Grand Theft Auto. Anything's possible. Literally, all the technology that we have now is trivial, absolutely trivial compared to what we can do. What you can do inside Grand Theft Auto is trivial compared to what the hacker can do who's writing the code.
Would you list a few?
Sure. One thing is the Andromeda Galaxy, our nearest galaxy, is like 2.3 or 4 million light years away. That's our nearest galaxy, and there are billions of galaxies, at least billions of galaxies. So getting there is a bit of a problem. Getting to our nearest neighbor is a bit of a problem going through space.
Yeah, but you have to abide by the speed limit.
Yeah, you can only go the speed of light. And so and if you're massive, and hopefully we will retain our mass, we can't go the speed of light. So as long as you want to have a body, you cannot go the speed of light. And so even your great grandkids, you put them on the ship, they're not going to get there in time. And that's our nearest galaxy. So there's this whole, we have 46 billion light years across that we can see, or 92 if you look both directions or something. It's some massive thing, billions of light years across. And we can't get to the one that's only 2.3 million light years away, much less the tens of billions. So, but if space-time is the final reality, then we're stuck. I mean, we have to go through space-time, and oh boy, I'll just have to go faster and have great grandkids. But if space-time is just a headset, and we learn the software, we can just move ourselves from here to there. Just like the person and the geek can take the Grand Theft Auto car and say it's no longer at Lincoln and 5th Street, it's now over here at 23rd Street and so forth, and just give them the new coordinates, and there you are in the new location. So we will be able to have technologies that are indistinguishable from magic.
Interstellar travel. What else?
Good question. I've been so busy with.
It's fun to speculate.
Yeah, let me see what other technologies. Because you can see my focus has been
of course
more
you're
on
not focused on
nailing
this,
down the technology itself.
One step at a time.
But that one was obvious. The Andromeda galaxy thing was obvious. Well, we may be able to warp space-time itself once we
time travel.
Yeah, because time itself is merely a projection.
Seems like you could bend reality at your will in many ways.
You will be able to, but not in the way that most people would think, where if I just focus and concentrate hard enough, I can change it. This will be technology. This will be, but it's going to be an interesting kind of technology. So here's the trick about it. The only tools we have are in space-time, right? So we have to understand how those tools are related to the structures outside of space-time. And that's what I'm working on the mathematics of that. We have to reverse engineer our headset in great detail. So, for example, cognitive neuroscience is the study of the brain. And most of us in my field have thought of the brain as creating consciousness, and it doesn't. But I still think we need more money for cognitive neuroscience, because what we have to do is reverse engineer the brain and ask, what is the nature of this conscious agent dynamics outside of space-time that projects into what we call neurons and neural activity, synapses, and so forth, because that's how our headset is being created. So once we understand cognitive neuroscience better and understand how to pull it back to the dynamics of conscious agents and the trace logic outside of space-time. So we're really understanding the details of our trace. What is our trace that's giving us this space-time headset? Then we'll be in a position to say, okay, what tools within because right now all I can do is use tools inside this trace. Now, I haven't thought about that. Now, is there any way for me to get tools outside the trace? That I don't know. I'll have to think about that. Maybe. But certainly we can use tools inside the trace, but we'd have to know exactly how those tools get pulled back into operations behind space-time in the conscious agent. And once we understand that, then we'll be able to manipulate things. It'll depend on how crude that mapping is, because we may be precluded from doing too much in the world behind space-time if our tools in the pullback are too crude. But my guess is that there'll be, even if they are crude, there'll be some new magic that we can do anyway. But then there's the question of, can we directly start to access tools not through our headset? And some spiritual traditions have talked about that kind of thing, where you aren't limited by the space-time headset. And I'm not writing anything away, but I'm saying right now those things are on the Schmistical side of things, where
sure.
where it doesn't mean they're not true. It just means that if they're true, they're not made rigorous enough yet for someone hard-nosed like me.
Yeah.
But they may be true, and I would want a hard-nosed way of saying that they work and why they work.
I mean, again, through speculation, but if it is technically possible and we get there one day, whoever would be the pioneer and therefore have control or ownership first would essentially have the capacity to play God, and that raises so many moral questions and power imbalances. And I know it's further down the line and it's not here yet, but if that is the case and these technologies are birthed, whatever individual, organization, country has access to such technology first, I mean, that would just completely change the hierarchy of...
Completely. What I would hope, maybe even expect, is that someone who really understands this theory of consciousness well enough to be able to do that technology would deeply grasp its implication that what you do to others is literally what you're doing to yourself. Not figuratively, not some platitude. You are literally, when you torture that person, you are literally torturing yourself. If they really grasp that, then I think they'll be careful how they open Pandora's box.
It's a good wish. It's a good wish. And
But your point is well taken. I'm not dismissing your point at all.
yeah,
It's well taken.
no, just a thought, I think.
No, it's an important thought.
Hmm. What other thoughts around when you look at the Fermi paradox?
Yeah.
And you look at how big and vast this universe is with seemingly no observable life. Why is it so silent out there? If there is potentially, probabilistically, so many more inhabitable planets with similar conditions to Earth, yet we cannot pick up signs of alien life.
Right.
I'm just curious your thought process around how alien life could very much so be operating through different rule sets or a different headset in which would explain why we cannot in this third dimension interact or seem to pick up them to
Yeah.
the same degree we would originally think. So I'm curious what your thoughts are on are there if there are potential alien life out there in the universe, which would be more probable than not, that might be very well operating within a different headset of sorts, different dimension, if you will.
That's right. And it's been a bit of a puzzle, as you mentioned, the Fermi paradox. That it's a huge universe, billions of light years across. Um, if there's life out there, why haven't we seen it? What's going on here? And right now, there are no uncontroversial bits of evidence of life anywhere else except here on Earth. So it's quite an interesting paradox. And I mean, there's a great book by Sarah Amari Walker. She's worked with Lee Cronin and others on assembly theory of life. Very, very interesting theory. And I've had the pleasure of talking with Lee and on a podcast and discussing it with him. And they have a nice, interesting model of life where you have the assembly index for objects, and the more complicated, the more minimum steps required to build an object, the greater its assembly index. And if you have multiple copies of an object with high assembly index, then they suggest that's indicative of some higher information processing system of life. And so it's an interesting theory, but it's still inside spacetime. And even if you try to expand it outside of spacetime, it's still a more computational kind of model of life, an information processing kind of model of life. So my framework is different from that. And I'm saying that life itself is fundamental. There's no inanimate information process that gives rise to it. So it doesn't emerge from information processing of inanimate systems. That life itself, consciousness, is fundamental. So then your question becomes even stronger. The Fermi is, well, okay, if life is fundamental, why don't we see it? I mean, it's just here on Earth. That's very, very strange. So isn't the Fermi paradox really good evidence for the physicalist point of view? Look, it was all just matter from the beginning. We're just lucky on this one planet that matter got complicated enough that life and consciousness emerged. So get rid of your consciousness first theories. The very lack of life and consciousness elsewhere shows that the physicalism is really the way of thinking about things. And so I turn that around and say, look, life is all around us. Consciousness is fundamental. We have a headset that gives us 0% of that reality. So the headset is losing all this information. So the aliens, where are they? They're all around you. They're screened off by your headset. What you can see are other people. You can see organisms and worms and so forth. You can see life and bacteria and so forth. But when I look at a rock, most of us say, well, when you look at a rock, you're interacting with something that's fundamentally inanimate. It's not living at all. And I say, not at all. You're interacting with a consciousness, the same consciousness that you are, but your headset has given up. Your headset says, look, I'm not telling you all of reality. I'm telling you 0% of reality. And all I'm going to tell you now is I'm telling you about a rock. behind that rock, there's an infinitely complicated consciousness, of course, living. So life is there as well. So there is no principal distinction between living and non-living things. That's not a principal distinction. And people who've been working on the problem of life have been trying to give a definition. What is the principal distinction between living and non-living? And haven't been able to do it. And again, they're brilliant. The reason they can't do it is because it's the wrong problem. The problem is your headset is screening off life. It can't deal with the profundity of life, and so it desiccates it, literally desiccates life into what we call inanimate matter. But behind that inanimate matter, if you could take off the headset, there's life and consciousness that would blow you away. So where are they? They're all around you. Just take off your headset.
Actually, it makes a lot more sense when you look at things like the Fermi paradox and you're trying to find out why there isn't as much life bursting out there in the universe to the degree we would assume. But when you look at it from the lens of the limitations of our own headset, then you could see, oh, okay, it's just we have a very limited scope on what we can perceive as life, in the cosmos.
Absolutely. And we've always been told to be humble, and we always feel like, well, maybe I should be humble, but of course, that's just me trying to be good.
Mm-hmm.
But when you look at life through this lens, for example, the trace logic, and you realize that 0% of reality, then it's no longer just sort of like a good idea to be humble. It's sort of like it's in your face. If you're not humble, you're just flat stupid. So humility is just being intelligent, and being proud and arrogant is being really dumb.
Yeah.
It's really stupid. So if you think you've got the theory of everything and we're that close to, we're just a little bit more past the standard model, then it's easy to be arrogant because we're close to knowing everything. But when you realize, even if you get that next step past the standard model, 0% of reality.
Why is that good news? That there would be no final theory of everything, that reality itself will always transcend any theory we have of it. Why is that good news?
Because you'll never be bored. You'll never be bored, because from this bigger point of view, you are the one, the source, and there's literally no end of exploration of who you are and who your neighbor is. So your neighbor, and even that little worm, is a window, an aphid, a bacterium, are all windows. Even just a rock are windows on infinite exploration. So imagine a world in which at some point you'll know everything. That's a pretty boring world. Now I know it all, but that's all it was. Well, I think that's not the world we're in. We're in a world in which there's infinite exploration, and the exploration is you. You are, but you transcend any scientific exploration. I'm a scientist, so when I say that, I'm not saying don't do science. I spend my life doing science. I'm all for science, but I'm all for doing it very humbly and saying, I'm here learning 0% of myself, but it's a true representation, as true as I can, of this perspective on myself. But this is just one of countless perspectives. And when I die, I take this headset off, and it's time for a different perspective. So, and all the time I'm seeing all the different, these beautiful plants, a different headset perspective on the one consciousness. So it's great because there's never going to be boredom. There's infinite exploration, and a lot of the exploration will be done, as the mystical traditions have said, in silence. So I think that and I do this now myself in my own scientific research. Of course, you do your mathematics, you study hard, no nonsense, no BS. But then if I want new creative ideas, I put it all aside. and just sit in silence. And that silence itself is tapping into this infinite wisdom that everybody is.
I think breeds reverence back into the human experience, where from the purely reductionistic lens, not
Mhm.
that everybody embodies that, uh, the perspective of if it's all just a bundle of atoms, really the best thing that you could do is extract the most of it. You know, you could use it to your benefit how you will. There's no inherent moral value or effect externally in that aspect.
Right.
But from this perspective, when you flip it on its head in this chain of causality, I am reminded of Thomas Berry's quote that the universe is a communion of subjects, not a collection of objects.
Yes. Very, very good.
And the Vedantic lens of Indra's net. Are you familiar with that
Mhm.
imagery?
I
Yeah.
know them.
It to me, when you explain the trace logic and Markovian chain, like if it maps on perfectly with that almost
Right.
because there's this wide net and within each jewel is reflected the others within it. And so it brings the coherence and connection of all life into that image. I'm curious your thoughts there because it seems so conciliant.
I agree on both points. First, your point about that being a physicalist doesn't necessarily mean that you're amoral. In fact, I have
Of course.
many good physicalist friends, and they're wonderful people, and I trust them completely with my life and my kids and so forth. So I'm not saying that. I'm just saying, as you said, that these philosophies tend to have logical conclusions that move in different directions. But I agree with your point also about Indra's net, that there's something very, very similar in spirit, and so this could be, the trace logic could be a first mathematical statement of Indra's net. And in saying that, I would say not that it completely exhausts what the idea of Indra's net, but it's the first precise mathematical statement we could give. Maybe Indra's net is pointing to something even deeper, right? Maybe the trace logic is just the first baby step we're taking outside of space-time, and we will find, hopefully, much deeper structures, um, and 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 maybe thousands and thousands of iterations of that, all at some point, exploring the metaphor of Indra's net more and more precisely, deeper levels. I mean, maybe an inexhaustible um, direction to explore. And so I don't want to say, yeah, I've done it with the trace logic. I would say, no, maybe I've taken the first scientific baby step in that direction. And hey, we took a baby step in that direction. And let's first nail this one down. Let's really get the math completely secure on this. So every step outside our previous theories has to be really secure. Once we got that nailed down, then let's look outside the limits of the trace logic. Okay, that was fun. Now let's go on to the next thing. And maybe the Indra's net will still be a guide. Maybe it won't, but maybe it will be a guide to the next deeper step.
To me, this has so many far reaching implications on what it means to be a human. What is life? What is death? How does this to you change what death is? If there is no clear demarcation of a boundary between life and death, as we were speaking to earlier,
Right.
and death is then merely taking off of the headset, um, yeah, what does that change? What's your perspective on that?
Well, first, I don't want to sound like I'm more spiritual than I am. Someone put a gun to my head, I'd be afraid. I'd probably wet my pants. So I'll just put that on the table right away. So anything that I say after this that sounds like I'm super spiritual, I'll just put that right on the table. Okay. So, but now I'll try to think out of the box. Death, from this framework, conscious agents and the trace logic, is merely taking off a headset. And there's an infinite number of headsets, and in some sense, the whole point of being here is just to look at myself from this perspective. Nothing that I build here is going to last. If I build an empire worth $1 trillion, I'm going to walk away from it, whether I like it or not. I'm going to walk away from it. Any book I write is going to burn or be destroyed. Anything, so nothing you do here lasts. So it's not about making some physical structure that's going to last forever, because it's not. So what is it about? It's not about being important. Who was the most important person in 1753? Couldn't care less. Who cares? Who was the richest person in 1844? I don't care. No one cares. No one's going to care. It's not important. So what is this all about? Because nothing that you build lasts. No one that you love is going to live forever. In this framework, it was really not about living here forever in this little headset. It was enjoying this view of myself from this headset, learning about myself, and not being attached to this. This is just one view. This is not me. This is a really interesting view of me. Wow, this is really neat. Going to work, doing a job, cooking food, having kids, meeting people, doing podcasts. Interesting perspective on myself. And I'm going to walk away from all of this, and none of it will go with me. I just leave it behind. But that was a perspective on myself. And there's an infinite number of these. Once I learn to get with not to be afraid, not to cling to what I already know, if I can just learn to enjoy the ride. And this actually gets to the minimizing surprise stuff. So the trace logic actually is a little bit about this. Here I am in a particular trace. One way to think about growing up in this framework is moving to a bigger trace, right? Expanding my horizon, move to a bigger trace. Well, when you do that, if I'm on a little trace and I'm going to expand to a bigger trace, all of my transition probabilities, all the probabilities of, if I'm seeing red now, what's the probability I'll see green? Or if I do this with my cup now, what's the probability that it'll fall? Those probabilities are all going to change. So growing up means not resisting the unexpected. Because the transition probabilities are different on the join. On the bigger space, your minimal surprise model worked for your conscious states. It doesn't work if you want to expand your consciousness. You have to change all of your transition probabilities to be a new consciousness in the new domain. That means you have to be willing to not resist surprise. You have to be willing to, so when the spiritual traditions say you must accept what is, that's the key, that is the step in spiritual growth. Accept what is. It turns out the trace logic completely agrees. To go from where I am to the next bigger step, a join, I have to not resist all the changes in the probabilities that are required for the new join. That's what it means to be at the new join. And then once again, as I go even bigger, I will have to not resist those. So what the trace logic is saying is it actually, again, it either works or it doesn't. I'm not smart enough to make this stuff up. I just saw the trace logic. It probably isn't true. And so it's not me. It's really just the trace logic itself. It's so amazing. It basically says what the spiritual traditions have been saying. And that is, at every step, if you want to grow, don't resist surprise.
It makes me think about how the species that survives is not the smartest or strongest, but the most adaptable, the one that is has the capacity to be flexible and change with the uncertainty of times. And there is a great, in the Buddhist tradition, sort of understanding of the yardstick for your own degree of growth is essentially your equanimity throughout the ever-changing, impermanent phenomena arising and passing away, anicca, this impermanent flow of experience that we're always moving through in life, and our ability to not stay attached to one experience, positive or negative,
Yes,
is like that's a real growth as a human being.
I completely agree. And in some sense, the trace logic itself is just the logic of the experiences, but the measurable space behind it is what you're pointing to, and the spiritual traditions are pointing to. That is the real deep you, and that doesn't get changed or affected by all the play of experiences. So that equanimity makes sense in this trace logic framework. It doesn't in the physicalist framework. In the physicalist framework, your life hangs by a thread, and if something goes wrong with your body, it's extinguished. So you need to do everything you can to try to stay as long as alive as, because otherwise your consciousness is extinguished and it's completely game over for you. This other framework says, no, your consciousness is secure. The play of forms is just a headset that you're trying on, and you are so deep and infinite that you can play with an infinite number of headsets and never, completely explore who you are. So there's no reason to be afraid. But within the headset, it's interesting though. I guess putting on a headset for the source to put on a headset, it goes in with both feet. I'm not just going to sort of put on this headset. I'm going to put on this headset.
Fully assume the role of a separate self.
That's right. I'm going to really go in, and I'm going to be afraid. I'm going to and I'm going to have dramas, and I'm going to murder myself. I'm going to really go into this whole thing and experience the whole thing. Otherwise, it's not really looking at myself completely from that perspective. So it seems to be that as well, that you really do look at yourself from that perspective, and you go all in, so much so that you lose for a while who you are, and then you have to wake up to who you are. And that's why if you put a gun to me, I would pee my pants, because I haven't completely awakened to who I am, right? I can see now, but the process of really integrating that and understanding who I am as the one is still a process that I'm going through. And for me, having this mathematics is a help.
Yeah. Yeah, to me, it brings a lot of gratitude for the contrast of the good and bad things that we perceive in our life. I just think of on the macro scale of like the most grotesque assassinations and calamities that are happening on the planet, in contrast with the most beautiful grace and devotional love and outpouring, and like the full contrast of what's available within human experience is quite astounding. And when it comes to our own personal life and our own personal struggles and different things, I think it brings some gratitude in the picture that we get to have the experience of many different versions and different feelings and emotions, and what they all uniquely reveal about who we are in our true essence.
Yes.
And I know this is something that you've personally also been on in your own health journey with long COVID, with your heart. I'm curious what has come up for you on the human emotional, because there's of course the logical side where you can see and philosophize about a lot of these different things. But when it comes to approaching your own human insecurity, and not just what a potential, death or disease would mean for the people that love you, but also the urgency of your work and the imminent discoveries that are coming to bear fruit. I'm just curious, how have you navigated your own process around the uncertainties of your health and the whole process?
Well, it certainly has put my assumptions that I'm just a space-time physical object right in front of my face, and I can see that the fears that I have of death, going to an operation for I have had 2 heart surgeries, and I've had my heart restarted with electric shock 5 times and so forth since COVID. It's been not the way I had anticipated the last 5 years to be. But COVID completely changed the game, and it put my mortality front and center. I mean, I think I mentioned last time I texted my wife goodbye in the hospital one time. So it just certainly has. I've had the headset removal right in my face a few times, and the headset's going to be removed. And there's nothing like having it almost removed a number of times in the last 5 years to have it not just be an abstract possibility, but an in-your-face reality, and to see how I feel about it, and to see the fears that are there, and to face. I mean, of course, this is a complete fact, and I would have even 5 years ago said, yeah, of course I'm going to die, but not now, not now. I mean, maybe in 40 years or something like that, but not now. And you can sort of ignore it and put it away. But when you're in the hospital and you're texting your wife goodbye, it's no longer an abstract possibility. So I think it's helped me in looking outside of space-time more, but I then still see myself getting my sense of importance or who I am by what I might accomplish, what I might discover. And so I have to look at that and go, okay, to the extent that I get my sense of who I am by what I might discover and how important that might be, then to that extent that I still don't really know who I am, because who I am is infinitely greater than that. So if I'm still looking to be important in some way, then I don't realize who I am and who you are. That I like watching these videos by some Canadians called Just for Laughs gags. And they put people in all these unusual situations, and they all take them very, very seriously. They're worried, and then all of a sudden they find it's a gag, and you see at the end people start laughing and belly, and I watch them all the time. It just helps to laugh and so forth. It's really good for you, but it's also what life is like. We're taking it all seriously and so forth. But we're going to take the headset off and laugh. And that's what happens in these gags. You're taking it all seriously, and then all of a sudden you find out the whole thing was a gag, and then you just then people have a good belly laugh about it. And so there's that aspect about do your best while you're in the headset, but don't take yourself too seriously, the egoic self too seriously. But the thing to take seriously, very seriously, is that you are the source that's infinite, but so is your neighbor, your source that's infinite. And think about this in the context of death. This is one big important symbol from Christianity, right? The deepest symbol in Christianity is Jesus on the cross, being tortured to death in the most cruel way that people could imagine, and having it hours, the most utter cruel pain. And what did he say while he was in the process of watching the people who were hatefully killing him in the worst way that they could come up with? He said, forgive them. They don't know what they're doing. That's the deepest spiritual thing I've ever heard, right there. And that, that is the centerpiece of Christianity. And I think of all true religion is to have that attitude even in the face of people who are doing that to you. Now, I'm not saying I'm anywhere near Jesus. No, if I was on the cross there, I'm sure I would be pissed off, and but I'm saying that that's where my own theory says I should go.
Leads to that transcendent way of being.
But Hoffman's emotions are not there. My mind is saying, here's the theory that's going to take me there. I have a lot of spiritual growing up to do, and all of us do. But that's where the deep heart of Christianity and any true religion, it's not in killing the unbelievers, being angry with people who disagree with you. It's forgiving them in the very moment in which they're hurting you. And if we do that, our country will be a very different kind of country.
It's a different level of compassion when you hold the awareness of actions that are coming from a place of unconsciousness or unawareness, where it's really hurting the person doing it as well, of course, as well as other people that it's hurting in the external world. But you can have compassion for seeing people as phenomena unto themselves, Like if you see somebody who does a horrific thing and hurts a lot of people, but then you come to find out they have a brain tumor pressing on their amygdala, right. It puts a different context into the picture of, okay, I can have a bit more compassion for there wasn't full agency there. I just think that it's fascinating that you can extrapolate that all the way down, that there are many different forces within us that we would not say that are consciously chosen, but for the circumstances we were raised in or whatever, like, people need to be held responsible for their actions, and still we get to have more compassion for all of the experiences that led them to the point in which they would do those things.
I completely agree. Again, Jesus on this was very, very clear. In, I think, Matthew chapter 7, in the Sermon on the Mount, he says, flat out, judge not, period. Don't judge any. It couldn't be clear. There was no exceptions. He just said, don't judge other people, period. And then he said, and he also didn't say judge yourself. He said, notice. He just said, notice the speck that's in your eye. Don't judge the other person for just notice the log that's in your own eye, but don't judge your brother or your sister for the speck that's in their eye. So that is the heart of Christianity. Anything that involves hatred of the disbelievers, judging of other people, is absolutely not Christ. Absolutely not. Christ is absolutely no judgment, is complete compassion, complete love for your enemies. Love your enemies. Love anybody who's needy. That's the heart and soul. And the deep thing is what we've been talking about earlier. When you love your neighbor, you are loving yourself. That's the deep, deep thing. When you don't judge someone else, you're not judging yourself. Do you notice the speck? Jesus said, notice the log in your own eye. But he didn't say judge yourself for it. He just said notice it. And that's all. As soon as you notice it, you're no longer stuck in it. Oh yeah, I'm afraid. Oh yeah, I was mistreating that person. Oh, I was judging that person. So I'm not going to judge myself because I was judging you. I'm going to just notice. And that's, I wanted to kill all those people because well, that's, okay. Like, I'm not going to beat myself up. Okay, I'm just going to, okay, I noticed I was very angry. I wanted to beat you. Okay. Is Jesus mad at me? No, he said he wasn't mad at the people who were killing him. So he's not mad at me. It's a very, very different place. And the only way it makes sense is to realize that everybody is the source, seen from a different perspective. That's the only way it makes sense.
And I think for some of us, having the intellectual comprehension of that is supportive. And then for many, the taste or the experience of that being so, and through meditative, contemplative practices, move the needle more. We can take it where we get it, all of it's welcome.
Absolutely. And someone who's a slow learner like me has to do both.
I'm right there with you. Don, I am always so fulfilled by the conversation that we get to have. And it's such an honor, honestly, to be able to have this discussion, explore the emerging discoveries, when you get fired up about all of it, and then all the implications for how it changes when we leave these chairs and when people turn off this podcast, to move through life with a bit more empathy, with a bit more understanding, with a bit more awe and curiosity. And I think that's a great thing.
It was a great pleasure. Thank you very much, Andre.
Yeah. Is there anywhere you want to point people to? Any last things that are coming out, or just where do you want to point people towards if they want to get more familiar with you, your work?
Well, my book, The Case Against Reality, is more about the evolutionary side. There's a little chapter about consciousness being fundamental at the very end. And I'm working on a paper on the trace logic that we'll be publishing, a couple of papers on it, one mathematical and so forth. So there's nothing yet on the trace logic that people can read. So this is like my first time I've really been this deep in public with the trace logic. But I'm hoping within a couple months there will be something out there that I can give to you, and you can, if you want to, send it to your audience.
Sweet.
Publication. So this is actually earlier, even before my publications are out on it. So
no, I feel very grateful to get early access to some of the papers and things that you're sharing. It's so fascinating. Thank you everybody for tuning into this episode of the Know Thyself podcast. Let us know in which ways this was impactful to you, and I'll see you next time. Thanks, Don.
Thank you.